Good evening, y'all. Oops, can you hear me? I think so. I hope so. Strong start, as always. Hi. Welcome. This is also not Demilight current testing and connector selection. It's all just going so well. Hi. Welcome to another Sunday Night Nerd Fest. This is clearly the casual week, so you get to see all the behind-the-scenes chaos that usually, I try and take care of ahead of time when I'm not trying and getting the Demilights working. Lots of good news there. Lots of questionable news. So we shall see what happens there. For those of you who it's your first time joining us, which there might be a couple of you, hi, welcome. The streams usually go about this well, with a little bit of chaos. I don't even have the chat pulled up. I had it there for a minute, and then I closed the whole window. It's going just great. You're over here now. It's going totally fine. Yeah, we're going to build tiny little DMX moving lights tonight. It's going to be a lot of fun. Excellent. Put the chat where I can see it. I finally solved for those of you who were here the past 2 weeks, I solved my issue of my one monitor wanting to record via OBS and the other one not wanting to, so that's all very exciting and solved. It has to do with a new setting in Windows 10, it turns out, so that's just great. Yeah, so a bit of a fluster, y'all. Sorry for the couple of minutes of late start there. Our pizza and buffalo wings arrived about 6 minutes ago, and I'm not saying I was shoving them in my face, but I was shoving them in my face. They were very good. Yeah, we're going to work on tiny DMX moving lights tonight. Hey, Kenneth Finnegan, nice to see you. Oh, yes, who have we got here tonight? Hi, Nate. Hi, Chris. Good to see you again. Hi, Cookie. I'm not sure if I've seen you in the chat before, but welcome. Hello. Yeah, we're going to build little nerdy things tonight. And so, okay, so confession time. I thought tonight we were going to be, all talking about how good version 0.9.3 of the mini moving light was and all the improvements we've made and all the great things. But there's a problem, right? So I have this little guy here, and I have his twin. And here, so first things first, great things about Demilight version 0.9.3. I don't know if Palmer is lurking out there again, but he was the one who first suggested using these little pluggable Phoenix connectors instead of the little 0.1-inch header pins we've been using. Awesome across the board. Just the ability for me to be like, oh, I'm going to unplug the light, and then I'll plug it back in confidently, and it'll do its thing. How wonderful. And if I want to make some lights twofer, I would just need to, do a little fitment here where I jam some, multiple wires into the same terminal block, or, I could build a little board that had multiple of these connectors on them, or what have you. Lots of different things we could do. In fact, it occurred to me, though I did not order the new sort of power and DMX combiner PCB that we talked about last time, that PCB would also serve sort of as a 5-way splitter. Oh, you're the one who sent me that truss. Yes, thank you. Yes, Cookie, also I think called Dave from your Twitter handle, if I'm remembering right, or David, did a really cool design. We're going to pull that up in a little bit. Some really cool modular truss designs that I'm stoked to use, because as I think I've shown you, I have a very rudimentary, triangle truss that I use just to have a place to store things, but that sort of multiple, it's got corner blocks and hanging brackets. I'm super excited. I have not printed any of it yet, but I'm super stoked. We got two Daves now. We got a Dave and a Dave. Oh, and Palmer and Katie are here. Hi, Palmer. Hi, Katie. So all of you should celebrate. And Palmer, I was just saying, you probably heard, that I love the Phoenix connectors. Just the ability, really honestly, as I was working on the lights this afternoon, even the ability to be like, oh, I'd like to have a look inside what's going on here, unplugged, no problem, take a look at light, and then plug back in, confident in connection, Cookie it is, tremendous. So that is all well and good. The connectors, though, are not the problem that I'm having. The problem is this. So you may notice that I have two little tiny moving lights here, and they have, our 1 amp max now capped at half an amp internally LED chips here, except currently they're capped at none of an amp because neither of them want to turn on. And I'm not yet sure why, and whether it's an issue with just the assembly of these two, which it could certainly be, or is it an issue in the circuit, or what have you. I'm I'm not entirely sure. So I thought what we might do is just quickly build another one of these circuit boards, and I can sort of show you around the place, because I know we have some new people, and I can show you what things changed in version 0.9.3. We're not going to put it in a lighting case. We're just going to sort of assemble the board as is. I mean, it really will just be the board, the programming header, and we'll slap an LED and a heatsink on it, and we'll see what happens. And if that one doesn't turn on, I think that will be a real... well, it'll be a sign. I don't know if it'll be a good sign or a bad sign. Because in some sense, if it's a assembly error, that would be fine. We can go through like troubleshooting how we track down errors in that. If it's a design error, I'm not quite sure what we'll start with in terms of tracking that down. But that'll be what it'll be. So let me pull out another of our 0.9.3 circuit boards and a couple of components here. We can get started. So now I really hope it's a not necessarily a design error, because I do now have 10 of these little boards. So if they're all bad, then I will. Well, I mean, it's not like they were horribly expensive. These were. I'll zoom you in on that one. So I ordered these through JLC PCB, and these were, I think, with shipping, fully assembled, $60, and that's DHL shipped for 10 units. And the turn time was from order to receive. I ordered these late on a Wednesday night Central Time, and I received them Friday afternoon here in Chicago. Palmer says, if you put your power supply directly into the LED terminals, would it wreck other parts of the circuit? So, it's fair, Palmer. I should verify that the LEDs themselves are not both dead. I guess they could be. And we can we'll do that on our power supply before we troubleshoot this. I am a little more interested in knowing if the driver circuitry on here, which on this is that little chip, which is the AL8860, and then these surrounding components, and actually this big inductor as well. If I've goofed that up somehow, that's going to be a more important thing to know than although I should definitely check the LED as well. I would be surprised if both of these were dead, sort of new out of box, but you make a good point, it is possible. So let's see. So before I get too off track, although I don't think anyone would be particularly surprised by me being off track. Kenneth, I don't think I ever acknowledged your trustworthy joke, and I just wanted to let you know it's there. Oh, here, we'll even update the title of the stream. This is the call it troubleshooting. That seems fine. For those who are here for the Python and Arduino classes that I do in the off weeks, or really that I do in the other weeks, if these are the off weeks, I don't know. Pretty casual about the setup of all of this. I try to be a little bit more prepared when I'm quote unquote teaching a class, but for this, I think it's more interesting for y'all to see what's going on under the hood there. All right, so I have this board. I need a programming header. I need a voltage regulator. I need a connector, and I need an LED. So let's pull those out. So first, we'll go to the PCB components bin. They're all the off weeks, yeah. Yeah, I mean, every week since about March 14th has really been an off week, I suppose. All right, so these are the Phoenix terminals. These are the pluggable header connectors that I'm now using. They're 150 mil pitch, right? So 3.81 millimeters, because that seems to be the smallest size that are readily available. The off weeks with the Demilights, yes, certainly, in the Python and Arduino programming weeks, we have a lot of good regulars, and I'm super excited to do them. But clearly, we have bigger crowd on these weeks, which is a lot of fun. They're also lower stress for me, to be perfectly honest, just because I feel better about leaping in without everything double checked. So these pluggable header terminals, for those who have played with Phoenix connectors before, they are a pretty snug friction fit. I'm actually gonna, because they're not, I need something to grab them by. There we go. On one side you can get them sort of in both ways of plugging things together, but this one solders into your PCB and has little male pins down in there, and then this one is sort of your free hanging connector, and you have these screw terminals on the outside that your wire gets shoved into. So when you want to make a connection, you just plug the two together, and then they come apart. So they don't actually lock, but the friction fit is really quite good. All right, so I have my Phoenix terminals. What else did I say I need? I need a power regulator, so I'm still using these cheapies. These were 60 cents a piece from AliExpress. They're a lot like the encapsulated. They're a buck converter module, right? So rather than the linear regulators we were originally using that were burning off all of our sort of excess voltage as heat, these are going to be a lot more efficient in conversion, which is going to be great because we're running the LEDs at anything from 12 to 24 volts. But we need 5 volts available for the processor and the servos. So being relatively efficient about it is... One of my lights is making a very unusual noise. I don't know how much the servo noise sort of comes through on the stream, but it's doing some interesting things back there. So I think we'll have a fun time with that tonight. So that's our voltage regulator, and then it's just the programming header and the LED. Yeah, it's like whining. I mean, to be clear, they are really... I think the technical term for this kind of servo is a craptastic one. They're the little 9G hobby servos like you would use for an RC airplane or an RC vehicle. Let's pull this apart here a little bit. Okay, so here's an interesting data point. This PLA that I'm holding in my hands is hot. Oh, the servo is quite hot. Oh, that's not good. I thought it was the LED getting warm. Which when we were dealing with hot casings last week is because the LED was heating things up, but this servo is actually really hot. All right, well this was the one that was making the very strange sound, so that's interesting. So this one that is not making the awful sounds is just like warm, like normal servo warm. Oh, in favor of fire? Well, yeah, we may get there today as we sort of test all these things. MG90s may be better. Yeah, I have a couple of MG90s in stock here somewhere that we could certainly play with. Part of the goal cookie is like just trying to keep things cheap for both for me and for anyone else who might ultimately build these. So sort of standardized the tolerances around the plastic gear servos I kind of like. So there's going to be some week when I just don't have anything prepared. I'm just going to turn the stream on and there'll be a campfire. There's a pile of components like smoking on the desk and I'll leave that for 2 hours. And that clearly would be like the breakout stream of this channel, you maniacs. All right, so in addition to those components... Ooh, I'm going to unplug this whiny servo here because that's going to make me a little crazy. Maybe I'll just unplug them both. Yeah, I'll turn the power supply off. Yeah, it'll be fine. So let's grab our header pins here, and we'll solder in. I'll grab our PCB vise from here. Let's see, where's the camera pointing today? Something like that. There we go. All right, and we'll put our board in here. So for those who've been here before, this board won't look terribly different. Remember to turn the power supply back on. I think the less likely thing is that I remember to switch the Arduino Pro Mini, that's my DMX source, from programming mode to live output mode and vice versa. I have done that like 17 times today, and it was just me. I didn't have to worry about like, talking or streaming or any of those fun things. So let's see. So this is my little ICSP header that I'm going to use to burn the Arduino bootloader onto my ATmega 328P. And to make sure that the spacing is right for an ISP cable, I am just going to use a spare ISP connector cable here. So we will... let's see. This is how much I don't care about this. You get the first shot of tummy cam tonight as I reach up and grab my blue painter's tape here. Classic method of holding pins in place while you solder them on, and other components as well. And like I say, we're not going to do the full assembly of tonight. Thanks, Dave. Yeah, I'm storing my tummy a little bit off-site. I have some new storage bins that are going to store that for me, hopefully. Though it being Thanksgiving week, and as I say, we did just stuff. I literally inhaled some buffalo wings, which was not the most fun I've ever had. It was very tasty, though. Let's see here. So what I like to do with these little header pins is, so I'm going to take my ICSP cable, I'm going to plug it into my headers here. So those are definitely in the right sort of spacing in relation to each other. turn this upside down, and then because this is actually 2 different little 1x3 headers instead of a 2x6, just because that's what I stock. So I'm going to solder 1 pin of each of them. Because really I'm just going to solder just... I feel like anyone who... Where's my face? There it is. Hi. Anyone who bet on me not turning the power supply back on should get like a half point for trying to solder with a cold soldering iron. So give me just a second here. Thank you, Kenneth. Get the safety glasses up by the tape. Here we go. My cool frameless ones. I've plugged the frameless ones before. I'm not plugged. I haven't sold them. It's a cold solder. Yeah, thanks, Chris. I really like these. So you may tell, I have a huge head and I have a huge like nose bridge right here. So any of the the solid phase 2 glasses, I always feel like I have a big black line through the center of my vision. So these clear all the way around ones, I really prefer. All right, so back to the table here. So like I say, with a nice hot soldering iron, I'm just gonna tack one of these pins in place. Clean that tip off a little bit. There we go. And then, with my iron still on it, I can sort of use that cable to make sure that those pins are all flush. I'm just pushing up on it from underneath. And then when that solder block cools, now I know that all 6 of those pins are really seated nice and flush against the board. And I can just wrap through and tack those all in place. It's 3, 4, 5, coming from the other side, sorry for the view, and 6. Okay, so there's that. So now I can pop this guy off, and there's my programming header. Let's do, just because it's, let's do the Phoenix connector next. I don't think I actually need the PCB device anymore. Set maybe for troubleshooting. So the holes, I must have missized the holes when I made this part in Eagle, which we did on stream last time, which was kind of fun. But you can see that the holes are like kind of significantly big for the pins, so there's a fair amount of slop. It's not awful, but I might size those down a little bit. And just like the programming header, what I'm going to do here is pick a pin that's not a ground pin, because the ground pin is going to be connected to a lot more thermal mass. I'm going to flow that, and then I'm going to check my alignment. So I'm kind of hanging out in space there. So now, because I only have 1 pin soldered, I can just sort of hold my iron on it, and then zhuzh the placement until I'm happy. Yeah, that's better. All right, so now I'm just going to flow these other 3 pins. I almost said other 4 pins, but you don't come to this to like learn what numbers are, I suspect. You come for the fire, as I'm rapidly coming to understand. All right, so that's gonna be our Phoenix connector. Doesn't that just look good? I mean, it's chunky, but like look at it just hanging out the side of the light there. I mean, and again, clearly there's some work to be done. Like, you know, I need some slightly different supports inside because we have a little bit of a factor going on there. But I think that actually looks really nice. And like I said, the fit in here just really feels really good. Like, to just ka-chunk, ka-chunk. Oh, very good. All right, so let's put the buck converter in here. Gonna match the color of the base of the connector color? No, not gonna get that fancy. I was just continuing my theme of so far it started sort of by accident and now doing it on purpose. Each of the generations having the generations of the 3D models having a different color of PLA. Just kind of helps me like real quickly in a bin see what parts are from what generation. And so I had a newish roll of blue, so I decided 0.93, which has the new big hole for the Phoenix connector, is the primary blue generation. But I'm reusing the parts from 0.91, which are this red. So a minimal amount of printing went into that. I've also, because I'm not sure this generation is going to stick around, I've only printed 2 of these bases, as opposed to the full set of 10 lights that I made for 0.91, of which I have built 4. Got a little bit ahead of myself. I mean, 0.91 is a perfectly functional generation, but these Phoenix connectors are just so swell that I like it a lot. Nice fade, a nice face from the cyan to black radiant. Yeah, so yeah, I'm gonna invest in one of those like really fancy RGB 3D printers. just to print like color matching bases on my tiny like $12 moving lights. That's you called it, Chris. I was gonna save that for sweeps, but no, you've hit the nail on the head, as it were. All right, so now that that is put together, we need to burn the bootloader onto it, which is also going to set our fuses correctly. So I don't know why I zoomed you out. All of this is tiny. So on the board here, you can probably see just next to the 6-pin header, there's a little silkscreen notch, little tab coming out. That corresponds to the little tab on the ISP programmer here. So we'll plug that in. So plug that in there, and then when I plug in my ISP programmer, just there, and that's upside down, but in theory, so this programmer is, I think, 11 years old and has some issues. And interestingly, now what's going on here? Did I not start this right? So what okay. So what I'm reacting to is there is an LED on this board, a red LED that's on the 5-volt rail. And so when I plug in this ISP header, which is providing 5 volts, that should light up. And it's not. So I'm just going to check my soldering real quick here. Yeah, so I've got actually a pretty bad soldering job, I would call that, on one of these pads. So let me touch that up real quick. This one is also not great. Do that real quick. Oh, not even on camera, but that's all right. It's embarrassing. Use a hot soldering iron. Didn't we swap FTDI adapters last time? Oh, we did. Yes, but that was for the DMX transmission. What we ended up swapping actually was the FTDI adapter and the mini USB cable. Because the other mini USB cable we were using turned out to only have power and no data, because it was one of those cheapy ones you get to like power an external hard drive or some nonsense. So there we go. So there's my red LED. So that was just all down to just bad soldering. So that's no good. I'll probably have to power cycle this. See, I don't know if you can see the green LED down in there that tells you it's active. That will sometimes just turn off. Like I said, I haven't gone through the why it's misbehaving, this programmer, but often just like unplugging and reseating the USB-A connector does the business. So that's kind of as far down that rabbit hole as I've gotten. So let's go to so we should attach an LED first. I guess we could burn the bootloader first and then attach an LED. So let me come over to my DMS device code in my Arduino IDE, and I'll just come up to Tools, Burn Bootloader, and we should see it writing, reading, and done. Great, so bootloader loaded, and that for the most part is just because I need to set the fuses correctly so that this is clocked. It knows what clock speed it's operating at. And then I'm going to upload this code using that same programmer. And with a little luck, this is when if it's going to crap out, it often does. But no, we're writing successfully there. And like I say, when it craps out, I just unplug and replug in the programmer, and that seems to work fine. Cool, so we're verified. So this now has our DMX device code on it. How do we want to do this? I wonder if we actually want to take a step back and just like, instead of trying to do this with DMX, let's put an LED on here and cause it to blink, or fade or something first. Let's do this in slightly different steps rather than just sort of charging ahead. So I'm going to need an LED, and we will double check the polarity on it. Because I thought past Jeff was particularly careful about like labeling the polarities of all the wires in these LEDs, but present Jeff is not like super confident in past Jeff's work. You can see one of them has like a black mark on it, and that should be positive on all of these. But, also these boards should turn the LEDs on, and, that should is a not. That should is not a true. Should true is no. So I'm no longer inclined to trust past Jeff's work in this particular instance. So what I will do, turn on my power supply off camera here. I've ordered black wire for you. Thanks, Dave. Then I would just have to make sure that I actually soldered it into the right place. Let's see, I'm going to turn my current limit on my power supply way down. Let's see. Yeah, turn that way down. I'm going to hook up the leads in the orientation that I think they are. Here, actually, you know what I'm going to do is leave you looking at my face for a second. I'm going to do a weird camera move with this overhead camera just so I can get the things I'm working on a little closer to me. And I'm just going to leave you looking at my awesome beard while I do it, just to not give anybody motion sickness as this thing wobbles all over the place. I think that's going to be better for any number of reasons. Okay, so now the workspace, yeah, this is actually much more comfortable. So let's see, power supply is on, voltage is on. Why are we current limiting at 0? Oh, there we go. Okay, so if I plug this in, yeah, there we go. Yeah, so that is the correct orientation. So the black wire is positive. Oh, Nate, thank you. That good point. Yes, I've not even cracked my beer. A bit of a scramble getting over into streaming position tonight. So tonight I am going to be having, I suppose, as I open it here, a Light the Lamp still single, or a still single beer from Light the Lamp Brewery. Here in Illinois, which is it's kind of a session-y Belgian pale ale. I didn't even think about that, Chris. Yes, it's so perfect for what, hopefully it's prophetic and not ironic by the end of the night. Yeah, that's, I didn't even think about that. I've had this beer several times this week. I think it's very tasty. Sort of, it's like, there are times in life when you want a nice mild session beer, and there's times when you want something a little bit stronger, and this kind of like fills the nice gap in between because it's a 4.5, it's very session-y, but it's very, very tasty. Also, like in the off weeks, I don't have a filler to give me an excuse to drink beer, except to say, cheers. Hope you're all doing well out there. Anybody drinking anything particularly interesting tonight? Like I say, no pressure to be drinking on any evening ever. Water is great, hydration is great. I just like to have a beer at the workbench, so. Ooh, cocoa. That sounds very good. Cookie, are you somewhere? I know Kenneth's out in like the warm part of the world, I know, and I think Nate is as well. Cookie, are you in a colder clime that's already wintry like we are here in Chicago? All right, so this was correct. So let me put this power supply aside. Oh, California as well. Is it finally getting chilly out there? I am originally from that region. Cocoa with Kahlua. Ooh, Dave. Yes, A+. Goose Island BCBS. Yes, very tasty. Oh yeah, lots of good options. 60-40, okay, and 35 at night. Yeah, that sounds like a California winter that I recall. The bitter cold of the California winter. 39 in San Diego. It was probably warmer here today. Like it was like 45 this morning for the dog walk. When my wife did the dog walk, to be clear, I didn't get up till 10 a.m. But that's, our arrangement. So let's see here. So let me solder this LED in place and then see if we can determine what the heck is happening. Because we know the LED is good, we know the polarity is correct. And it's certainly possible that like the error is somewhere entirely different from being in these circuit boards, right? Like it could be, I have an error, but the thing is, excuse me, the DMX code that we're using, both the sending and receiving, hasn't really changed since last week, and it was all working just fine. And the fact that it's like ballyhoo when I give them power in DMX means they are receiving DMX, right? They wouldn't be doing that dance if they weren't. So I'm sort of suspecting hardware issue, but I don't really have any firm proof of that. But yeah. So this seems like a place to start. So rather than jumping right back into DMX, I think we're just going to, make this light like fade in and out. And let me double check. So like, that doesn't matter. I was gonna tell you why my mouse is where it is in the desk, but that's like the least interesting thing. Let's pull up our schematic here and see. So this is the AL8860 chip that we're using to dim the LEDs, and its control pin, yes, is digital pin 3 from the ATmega. I just want to double check that pin number. And we may be coming back to this view in just a second here if it looks like we do have a hardware issue. Because this would be a good place to start tracking down where that error might have occurred. But for the time being, let's just do a real quick bit of code to test that LED. We will say, I'm going to use magic numbers. We'll say pin mode 3 output. We'll do a loop for int I equals 0, I is less than 255, I plus plus. Analog write pin 3 level I, and delay, let's say we want to loop a second up and a second down, so about 4 milliseconds in between. And then we will copy and paste this loop, except instead of going from 0 to 255, it will go from 255 to 0 and decrement by 1. All right, so, oops, there's my save window. So I'm going to save this as, I don't know, light fade test. And when I upload this, what we're hoping to see, just to be clear, is that when I upload this to the board, the LED should fade up to full and then fade down to 0 in approximately 1 second each. And actually, just for safety, I'm going to slap one of these here heat sinks on it, just in case it does turn on. Because we know from our experiments a couple weeks ago that half an amp continuous, at least half an amp dimmed, is just about what we should expect to put through these things with a heatsink on. So if we're gonna be fading these up and down to full, a heatsink is not a bad idea. I'm gonna use some of my little heatsink thermal adhesive tape here, which as I was using today and reflecting on how cheap it was, like, this is probably not a particularly great product, but cheap and not a great product are kind of the themes of this project. So, I think that's very much in line with the rest of things. Let's peel that off. This is a bigger heatsink than I would use inside the lights, just for a little extra safety. You could be safe and add more fire. Yeah, that's true. I mean, there's always, as we know, there's always room for more fire. All right, so we will plug our programmer back into the board here. All right, and there's that little 5-volt USB, or not USB, 5-volt rail light there coming on, which is a good sign. There's our LED. So let me come back over here to the computer and hit upload. Oops. Oh, yeah, so it's doing that thing that I told you it would do, that it... Oh, weird. I have some weird sizing issues. Look at how goofy that is. Oh no. Don't do that. Don't shrink away. Hang on. Let's make this better. Oh, what I was referring to here is, look at how this computer window is spilling out of its border so sillily. Let me fix that, or it's gonna make me crazy. This is a byproduct of switching screens that I was streaming from a couple weeks ago. It would capture my laptop screen, but not the external monitor that I use as like a streaming monitor over here. Doesn't really matter, but that is a goof that I did not catch. All right, where were we? We were going to upload some code. So that got reset. This gets uploaded. Upload. Oh, you know what? It's not gonna do anything because it needs power. All right, but that code is uploaded, so that's good. So this LED has a forward voltage of something like 11 volts, or it's 3 white LEDs in series. So the voltage input here that would normally come into the Phoenix connector has to be at least 11 volts. So let's power this from our power supply at 13 or 14 volts, and that should do the trick. Do I have a bit of scrap wire? No. All right, let's not go to extreme tummy cam, because where the wire is stored would need... You'd be all... Listen, all the cameras are all up in the business, as it were, here, so you don't get to see that. I'm sorry. You can... No, never mind. You can subscribe to my other channel if that's really what you're here for. There, we're back. All right, so what I've got here is a couple little bits of solid core wire. I'm just going to shove into these. This is the other nice thing. Thank you again, Palmer. 10 points to Gryffindor. The other nice thing about using these Phoenix connectors is it makes like troubleshooting connections really, really easy. Because I can just shove wires into these terminal blocks and tighten them down, and that is awesome. Let's see here. So, ground and power. All right, and we're not doing the DMX connections, right? Because this is just going to be to test whether, does this iteration of the board actually cause LEDs to glow? And we'll see what happens. So I'm going to, power supply is off. I'm going to hook up power and ground. And I'm going to reduce the voltage a bit and up the current limit. So now, we have 10, 12. All right, so the forward voltage is, the voltage coming in is now 14 volts, which is well above the forward voltage of this guy, and it's not turning on. That's a bummer, because it probably means there is a design error somewhere in my board. And I wonder if I've just spotted it. Let me, before I commit myself too much. Yeah, sad trombone. I don't know. It feels too, as you can probably tell, I'm not a streamer. I just like to share these things online. I did stumble across with the Stream Deck that Nate thankfully helped me out with. Thanks to you again, Nate. Has like a soundboard feature that you could like play sounds. So maybe we need like a womp womp sound for sad things. That feels like maybe like a little silly too far, but it happens often enough that maybe, I guess maybe it happens too much, like maybe it would get overblown. All right, so I'm gonna take my multimeter here and set it to conductivity. Power supply is off. So here, let me show you what I'm wondering. Let me get another PCB out here, because, where are you? Here we are. I wanna show you, what I'm looking at, and this is becoming more cumbersome. So you zoomed all the way in? Yeah, for sure. Let's be a little wobble cam here, but maybe a better pointing stick because the components are so small. What's going to be a good? Here, I'll use this guy. So this is the AL8860. That's that part we were looking at on the schematic that actually does the LED dimming. And the gist of its functionality is it basically puts the LEDs, which in this case are connected to these two pads, the LED plus and not plus. It basically puts those in the feedback path of a buck converter that is formed by this external capacitor and this inductor. And it does current limiting based on a couple of different control sources. The resistor here, which on the schematic, which I'll take us back over to, is represented by these two resistors, R6 and R7. R6 and R7 are this surface mount resistor and this pads for through-hole resistor, to give us the option to parallel this resistor with something of similar size and sort of, reduce this resistance here, which increases the maximum current out. So this resistor pair sets the maximum current that it will be output by this driver. And from there, you can dim this down further by applying a pulse width modulation signal to one of the control pins. That's interesting. So this is not what I was thinking the issue was, but can you see? So the AL8860 comes in two different form factors, this TSOT25 form factor and this SSOP 08 form factor, which is this down here, which is not populated. And the availability of each of these goes back and forth on JLC PCB. So I just designed this PCB to be able to take, whichever one is in stock. I can say, we have the TSOT25 form factor ones this week. Then cool, well, stuff that one and leave this one off. Oh, we have a bunch of these in stock, stuff that one, right? Just for a little flexibility. What I'm seeing is on this SSOP footprint. Can you tell there? The two pads right there are bridged. Pins 1 and 2. Here, I think I can get you even closer. If it'll focus. Yeah, I don't have a bunch of light that close to the camera, but you see right here, those two pads are bridged, which they definitely shouldn't be. And in fact, there's a solder bridge between some of the other pins here too. I wonder if that's causing some of our issues. Isn't that interesting? What I was going to say is I was going to test connectivity between this sort of current limiting resistor, our set, the current setting resistor, and the two pins it's supposed to be connected to on the AL8860 here. But I should come back to that too. Nate says, are all the boards like that? Oh, that's a good question. It'll be a little bit of a bugger to get them out of this, but let's take a look at some of the others in our stack here. Try and keep my... Sorry, you're getting like full like inspection nose cam here. Here, let's see. Oh, yeah, this one is. This one is that way. How about this next one? Yeah, you know, it's so perfect. Let's make sure it's a bug and not a feature. Hang on, let's go back to Eagle. And we'll look at our board layout. Oh, no. Oh, yes. So then this is that part we were looking at. This is that 8-pin SSOP bar. Doesn't look a lot bigger on the circuit board here. So if those were bridged... Oh, no. This is the wrong part. I'm sorry. This is the Max 485. This is the DMX receiver chip. This is the part we're looking at. Okay. Whew. Well, so this is a feature, right? The fact that those two pads are bridged is a feature because this chip really only needs 5 pins: ground, raw voltage input, the switch input return, your PWM control line, and your voltage set pin. On this 8-pin package, they just doubled them, a couple of them up, and including it looks like these switch pins are supposed to be bridged. Well, that's on me. That's my error. Good. Let's come back to these PCBs, though, and have a closer look at that footprint again. All right, so let's see here. Is anything else bridged? It's a little hard to say. It doesn't look like it. Yeah, I know, Cookie, right? Like one is unfortunate, a bunch is like not great, but like, yeah, I'm not going to be able to get too close enough to really see without a macro lens, but it's such a perfect little bridge in there that, yeah, that's a feature. I don't see any consistent bridging on the other pins. All right, so we maybe can throw that idea back into the pond for a little while. Let's go back to, let's just measure some connectivity tests here. Just see if these are yes and yes. Okay, so those are functional, or at least connected. Let's see, I could do some voltage measurement of, here, I'll take you back to what I'm looking at over here. I'm just checking so this raw pin here, which is both that side of that resistor, that's probably the easiest place to measure it. What I want to see is, do I have where? Oh man, sorry, you've been looking at my ear this whole time. Oh, and this computer is all messed up again. Jeez. Yeah, this is the kind of quality you can expect from these streams, I suspect. Yeah, there's probably going to be more of that. Let me swap back to... There we go. Hi! So I can look at the computer and you're not having ear cam the whole time. What I'm looking at here is this raw network, which just is literally the voltage input from our voltage in pin through a little Schottky diode for reverse voltage protection. I'm thinking about redoing this, by the way, with a P-channel MOSFET. I think that will be a cleaner way to do the reverse voltage protection, so we might do that tonight. But so far, this is kind of shaping up to being a troubleshooting night here. All right, so what I want to do is turn the power supply back on and see if I really do have my full, 14-ish volts present at my resistor and my control pin here. So let me do that. Set this to DC mode. I don't know. I'm gonna move that spurious mouse think it'd be more interesting. Yeah, there we go. So I'm gonna need a ground pad. I'll take it off the servo pins up here and take that pin, 14.5 volts. That is about right. So that's good. Let's just measure at the IC itself. Yes, that's right. Okay, so power is getting to the controller chip. I guess I could see if the... so here's a thing that's occurring to me. Turn the power supply off, place your bets now. Let's go back to the schematic for a second here. So this kind of awfully laid out schematic, this annotation here, this D3, references the fact that that pin is tied to what would be digital pin 3 on an Arduino setup on the ATmega328. That's pin 3 on port D, just there. But I'm also tying that control line to ground through a 10K resistor, just so that if for whatever reason in my code I'm not asserting that line to be at any particular level, this is going to pull that control line to ground and the LEDs are going to turn off. So what I'm now wondering, if it's possible, is I want to take a look at this line, which should be getting that PWM signal from our Arduino, our microcontroller, and see if that PWM is present or if this is just being constantly pulled to ground, which could also be a hardware issue. Let's just double check here. D3, 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 pin 3. Okay. Yes, and let's double check that our code really is talking to pin 3, analog rate pin 3, pin mode 3, output. Yes, okay. So let us... How do we want to approach this? Do I want to probe it with the skill? Well, what I first want to do is take a sip of beer, but while I do, I want to ask, do I want to probe it with the oscilloscope, or do I want to do a connectivity test with the right pin on the ATmega? Let's think about that together. What? My wife is shouting oscilloscope from the kitchen. So that's a strong vote for oscilloscope, I suppose? Oscilloscope?
Yeah.
Okay. Noted. What does Winnie think? Winnie thinks pizza. Our dog thinks pizza, but she's always thinking pizza. Stand by for beer. Okay, well, the wife votes oscilloscope, so that seems like a way to go. So it's gonna be a little bit tricky. I wonder if I have the view that gives us the call it the oscilloscope. You didn't? Yeah, we're standing by, Chris. Chris, stand by. I have a view in my streaming software labeled oscilloscope test. Let's see what it looks like. Not much is the correct answer. Yeah. Oh, I know what that's from. That's from when I was trying to use yet another webcam to do that. Let's see if I still have an oscilloscope view. I don't think so. I think the best I'm gonna do is this view. Oh man. Yeah, this is gonna be not a non-ideal view of the oscilloscope, but just so you get a little bit more of a visual about what's going on. You know what I am gonna do is I can help with this flare a little bit, which will help just a little. Let me. Where is my... Yeah, all right. Gonna have to mute on TummyCam. Not TummyCam. I'll just... It's fine. Why do I explain? I'll just do things, and then you'll watch them. Who's gonna stop me? Good guess, Chris. No, not Velcro. Black tack. This is actually City Theatrical branded black tack. It's a high, Chris knows this very well. It is a high temperature tape. It's a aluminum foil based tape. Wow, there's so many cameras. Hello. So I'm gonna stick this. I have the light that's glaring on this is the light that's lighting this table here. So I'm just gonna put a little black wrap flap on it. just to help with that glare so we can maybe see that screen a little better. You're getting some glare off it. Well, that's not a whole lot better, is it? All right, one more piece, and then we'll just soldier on. Yeah, that's an expensive toy, but you know, in the home shop here, it lasts about 100 years. I really don't use that much of it. I have some cheaper like silver ducting tape that I use for a lot of my like heat sensitive things. Because I don't need them to be black, but in this case, I think it's actually helping us. All right, what was I showing you? Oh, oscilloscope, right. All right, so this is my little cheapy oscilloscope here. That's not the worst view. It's not the greatest view, but let's see. And I think, yeah, so here's my scope probe. I'm gonna do some bad probing here. So there's our table. And I'm actually going to just strip this ground wire back. So you want to keep the ground connection of your scope probe like as close to the point you're probing as possible. Obviously, this is not particularly close, but also the signal I'm looking for is at, you know, a couple kilohertz. So like, I don't think it's terribly critical. We're not really looking for signal integrity or signal quality. We're just looking for like, is signal, am signal, please. All right, so before we turn this on, let me remember where we're actually going to be scoping ourselves. I think we're going to try and hit one of the pins on the microcontroller, on the LED controller. Oh, well, of course, now the camera that will be looking at my face is now the camera that's pointed at the oscilloscope. So we'll just go to the computer there, or you can just pretend that my face is an oscilloscope, which is fine. So I'm going to probe here at pin 3, which is opposite this set pin here, closest to the other part. So I'm going to try and probe this pin on the AL8860 there, and we'll just see if we have a pulse width modulation signal there. And if we don't, then I think we'll try and track that back upstream, because that would certainly be one reason why these are not turning on. I have a thought why that might be, if that ends up being the case. But let's not get ahead of ourselves. Let's probe the thing. And I'm going to check the settings of my oscilloscope. So I'm on probe 1. You probably can't see this, but I'll read it to you. I'm at 2 volts per division. Let's go to 1 volt per division. We're at 250 nanoseconds per division in terms of time. That's pretty extreme. Let's go to 5 microseconds per division in time. Yeah, nothing else for it, really. Just turn it on. All right, so power supply is on. Power LED is on. It's a good sign. You know, I'm going to continue to futz with this camera, because for probing a TSOT part this small, I really would like to be in a nice, comfortable position so I can really get down in there. Yeah, that's better. Sorry for the swingy view. Okay, so I've got my power, and let's see. So I'm going to probe that pin. Well, it certainly doesn't look like we have a signal there, does it? That should be getting our PWM signal. Let's make sure we're not in 10x mode. Oh, we are. Okay, well, still, we should have been seeing something. Yeah, nothing. Let's trace this back along the traces. So here at the resistor, nothing. Here, we can do this on the computer at the same time. So should be, here, let's give ourselves a view of all of the traces. This is almost certainly one of the traces I redid for this version, which makes me a little nervous. So here, all the way, so here's what we're looking at, right? So I was probing this pin here on the AL8860. Here's that resistor, right, that's pulling this line to ground when it's not being asserted. Again, sorry for the ear view, but the oscilloscope is being my face. So we're passing through this other pin for the other footprint of the AL8860. We go under this via, we go under the bottom layer. That would actually be a really easy place to probe. And then this line, this D3 signal, comes all the way back and comes to pin 1 of the AT Mega. That actually would be another easy place to probe. Let's probe the microcontroller directly. Enable switch? I wish. This one doesn't actually have, this one should just be, so we have no PWM there either. Oh, Well, we have something there. Maybe I'm doing a bad probe. Ah, I have a bad ground. Is also not helping. Let me go there. I see I have something. Oh, what I might be seeing, I might be slipping my probe onto pin 2, which is digital 4. Pin 4 is the receive enable pin for the Max chip here. Well, that's something. What is that? Slow that down. There's our PWM. What are we... Let me change some settings here. So channel menu, let's do DC trigger coupling. Yeah, there we go. Or DC channel coupling, I suppose. Let's move this down so we can see it a little better. Yeah, so that's our... I'm having trouble keeping the probe in the right place, but that's our PWM signal. Which is a good sign. Okay, so the microcontroller here. Let's eliminate one more variable. And again, my face is an oscilloscope. Let's just write a whole. Let's not even bother with changing the levels and fading. Let's just lock it at a level so that those pulses in the PWM loop are of constant size. So we'll say we don't even need a loop function here. We'll just do analog write pin 3 at 25, which is about 10%. So to upload that, I will have to plug my programmer back in, turn the power supply off. Don't actually have to. Just whoa! That's a warm board. That board is hot. Oh. This is hot. That's very hot. This, those of you who are waiting for fire, you might have your wish. Why is this buck converter so hot? I mean, clearly somebody did a bad soldering job on the pins there, but it's still grounded. Not great. Ooh, that's screaming hot. All right, well, that's interesting. In some ways, user error is the best error because all you have to do is swap out the user, right? And that's when the user is all me. Do we have continuity between ground and anything? I'm not quite sure what you mean, Palmer. Chris asked backwards. It's a good thought. According to its no. I should be all right. Here's an old version of the board. They are the same, and look, I've got labels here that say in and external, and the in is definitely on this side because that's where that big power trace goes. It feels more to me like something is shorted. Like this is trying to put out, the maximum, as much current as it can. Like something is maybe shorted on the 5-volt rail, which we could check. Yeah, Palmer, we're thinking the same thing. If it's really just a dead short, that would be easy enough to check. My fear, if it was a dead short, I wouldn't think assuming it's the same problem on all of these, and that's an assumption, right? That may not be true, right? It could have 3 totally separate issues, as we've seen. If it was a dead short, I wouldn't have thought we'd have enough power to run the microcontroller and the servos. I worry that it's an issue with somehow with the LED driving that's causing the issue. Although the LED driver is not really present on the 5-volt rail in any meaningful way, so I'm not sure where to go from here. But let's just check some continuity here. So let me find a really easy point to look at the 5-volt rail. Oh, so the servos take 5 volts. So let's just meter. Yeah, so no continuity. So the servos, right, their center pin is positive. This outer pin here is ground. So no continuity there. cooled down now? Yeah, so no shorts. So I have a short on... No, the LED is not a dead short. Oh, except... Huh. Those pads are reading a dead short. Or not a dead short, like a 5 ohm short. Which could be... Is that... Let me get one of our unpopulated boards, which may be more... Oh, need a FLIR camera? I will say I have been ogling the cheapest version of thermal cameras just because they're... Yeah, so this board too. So it's not a problem with how the LED is soldered. Is that true on older boards? No. Ah, okay. Yeah, so this is... I don't know what generation this is. This is an actual 091 board. This is the one that we were bodging together that we had to, before we made the containers, the bases taller, that we had to cram this board into a shorter base. But that does not have that same, you know, if I pull the meter in here, we'll see when I meter between the pads of those LEDs, it's like 5-ish ohms and dropping. And dropping, like a capacitor? Oh, here's a question. Could I have put the wrong capacitor somewhere and it has failed closed because I put too much voltage on it? I don't know. Kenneth, you might be the person to know this. Do a cheapy ceramic capacitor more likely to fail closed or fail open? Let's see what we've got here. So those two pads of that LED pin are, so the LED here is represented by this jumper J2. So I was metering between those two pads. So what other paths connect those pads? I have this diode, which I guess I should check orientation on. Kenneth says ceramics usually explosively open. Kenneth, that's true for like an overvoltage situation? Yeah, if you just put say in my case 24 volts on like a 10 volt ceramic cap. What other? I mean, I don't know what's internal to this that could be metering as a low resistance. Like there could easily be a FET or something. Well, except like this circuit is not really that different from the version that does not present in that way from version 0.9.1. Is it the inductor? Is it the let me measure the resistance of these resistors for realsies. We're down a whole different rabbit hole than I thought we might tonight. Might go down, but I'm not sad about it. Because I think we're gonna learn. I mean, clearly we're gonna learn something. So that resistor, yeah, should be 0.2 ohms, 200 milliohms, and within the resolution of this old Menards multimeter, that seems about right. So why here? Let's do this in. Okay. So okay. So that I'm thinking that resistance measurement we were seeing in conductivity mode may have been a little bit of a red herring, because look at this. So here's the two pads that our LED are connected to. From pad 1, we go through our, couple hundred milliohms of resistance. Let's go the other way, right? So we go through our inductor, we go through our Schottky diode, we go through our tiny resistor and back to the other pad. At DC, right, this inductor looks like a short. And at a small DC measurement voltage, this diode probably still forward conducts, at least into its linear region or so. So we get a few, we basically get a few milliohms of resistance across these two pads, which is what I am seeing on the multimeter here, right? So if I bring this in, I'm on resistance mode. I measure, and and I get, you know, a few milliohms, which makes sense. If I switch this to conductivity mode, typically this conductivity measurement is happening at something like 10 kilohertz, I want to say. And at that frequency, this inductor starts to have a little bit of impedance. So when we measure the resistance in conductivity mode, we should see a slightly higher resistance there. Yeah. So a handful of ohms at that point. Okay, so that does make sense. What doesn't make sense is why would that not be true in these two very similar circuit boards? Like, what is it about this one that's changed from this one? And the answer is not a lot. I did change the layout of the LED driver circuitry here. Maybe I made a goof there. I don't think I changed the schematic really at all, but we should go and double check that. Ooh. No. I thought maybe I had a short between the inductor and the LED pads, but I don't think I actually do. Let's look at that closely. I mean, the spacing there should probably be improved, but I don't think I'm actually shorting there. Doesn't look like it. Now let's open the schematic for this guy and let's see if maybe I could be crazy. This logic may not actually apply. Let's come back over to ye olde computer. Come back to our project and I will open the schematic for 0.91. Yeah, it's the same. It has not changed, except for the addition of that paralleling resistor, which is not populated on either of the boards. So let's go back to our layout for our current PCB and see what I might have screwed up. Because that's really the only place not that much changed between these two versions. Well, let's do a not an ERC. Let's do a design rule check on this board to see if anything is like just not routed. I have some overlap of nothing with nothing here, that's fine, and then a bunch of wire stubs which are just like I drew over a net twice, right? So like there's some overlap, but no other DRC errors. You know, I maybe have jumped around a little bit. Oh, Palmer, thank you. I'm having fun doing it. I never know if the troubleshooting part is actually interesting or mind-numbing. So at least Palmer likes it. I'll take that. So thanks, Palmer. Appreciate it. Let's go back to a thread we were chasing earlier, which was back to a oscilloscope view, which is we had that waveform present at the Arduino, but not at the AL8860 itself, which is weird. And then we got distracted by the fact that this thing was burning hot. You know what? So what resistor? Let's show you the actual thing that I'm looking at instead of selfishly looking at it to myself. This resistor should be a 10K resistor. That's R8. Let's double check what resistor value I actually stuffed it with, because there are, here, I can actually probably see on the board here. I've covered you with me. There we go. I guess I don't need the safety glasses on right this moment. Oh, no, that's the right. That's right. So all the 06, 03 resistors on this board are 10K. Or should be 10K. And the only resistor that's not a 10K resistor is this 200 milliohm resistor that is the current setting resistor for the AL8860. So I was worried for a second, like if I shorted that line to ground with a 200 milliohm resistor, it's not a dead short, but it would cause this to try and push a lot of power through that one tiny resistor. I don't think that's the issue. Let's do the rest of that process there real quick. I am going to pull up my BOM that I submitted to JLC PCB, and we can double check what part I actually asked for them to stuff that position with. So I guess I could do this in the JLC PCB order as well. So R8, yeah, should be a 10K 0603 resistor with that part number. Let me load up. I'm gonna load up off screen here just a little bit because there's a possibility I'll have to, like, you know, show you my email or password, and that would be like less than I would, not what I would aim to do on stream if I can avoid it. But then I'll move it over for the salient parts. Or I won't, and you can just look at my pretty face learning things. Let's see, order history. No, I think it's going to show you my. It doesn't really matter, but let's see, assembly, product details. This I can show you. So this is. Let me make sure you're looking at the right thing. There's so many windows. Pro streamer. Okay, so this is the view that I'm looking at on, this is JLC PCB's parts assembly website. We looked at making PCBs through JLC PCB, I think on the Electronics Bash class ages ago. But for those who weren't here for what are quickly becoming the off weeks, this is like the actual parts I ordered from JLC PCB to stuff on my board. So I have a power inductor of my Max 485 chip to do the DMX reception, Schottky diodes, capacitors. Where are my resistors? Here we go. Resistors, surface mount resistor, part number C25804. So we'll go to LCSC, which is JLC PCB's parts arm. We'll search that part number, and we'll just double check. Yes, 10K, 1%, 1/10 of a watt resistor. Okay. So let us go back to let's go back to beer. Let's go back to beer for a second, and then we'll do the next thing. That is the La Croix that I was drinking earlier and still have some of, and I was expecting like a bitter beer experience, and instead I got like a grapefruit La Croix, and I was very jarring. Stand by. That's what I was looking for. Okay. Let us go back to tracing down why we might have gotten that PWM signal at the controller, but not at the control pin of the AL8860. I think let's just start with some continuity tests here. So let's see. So let me pull up. I think I can pull up like this. Yeah, with the schematic kind of on the side here. So let's meter between this pin, which you probably can't see super well there, but and of course this is also super screwy. This view of my computer here. Wow, I really did make a hash of this, didn't I? Shrink that back in there. There we go. So I'm going to measure between the pin on the microcontroller and whatever little via that goes to, which I think I can see on the board there. So just make sure this is in connectivity mode. Yep. So there's that, and this is the via. Yes. Okay, we'll have connectivity there. That via goes underneath and pops up just north of the other. It's this pin on the. Yeah, okay, got continuity there. But then it's straight from there to there. Was I metering the wrong pin? Maybe. Maybe. That's possible. That's certainly possible. Let's power this guy back up and take it for metering round 2 on ye olde oscilloscope as dictated by my wonderful wife, who is great. Some of you out there know my wife Mary. Some of you, I assume there's some of you who do not know my wife Mary. She's pretty great. My dog Winnie, also very great. That's a plug for Mary and Winnie. All right, let's turn Here, let me get oscilloscope view set up, because I probably won't want to leave this going too long, knowing that there's still something in this system that's causing things to get very hot, which I don't love. What is that glare? Oh, is that this? No, that's... I'm not going to spend too long on this problem, but the lighting guy in me, and I will always be a little bit of a lighting guy at heart, just wants things to not have glare. There we go. That's a little better. It's not a lot better. What is that actually coming from? Oh, I see. It's coming off of a different part of the light than I thought. Hang on. Make this better. This looks very silly in person. Hey, there we go. That's better, at least. And now we got the glare up from this guy up here. Well, it'll be fine. All right, so I'm going to turn on power here, and I'm going to probe where? I'm going to probe once again at the... oh, you know, before I turn on actual power, let's upload that code that was just going to put this at a... I don't think we ever uploaded the code. It was just like, hey, put this at a 50% duty cycle, and that's it. So let's do that on the computer real quick. We'll upload that. There we go. Writing. Done. Okay, great. So now we should just get 50% on. Oh, not 50% on. 25% on. 25 out of 255, so like a 10% duty cycle. Just something we can see that's consistent. If only you had some small movable lights, says Chris. Ah, ha, 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 very funny. I mean, the dream would be someday like the previous projects like line up on behind me and do a light show, but clearly we're not there yet. All right, let's get ready to turn this on and scope this guy. So let's move the probe here. And all right, so I'm gonna turn this on, and I'm going to probe at, let's say probe at the microcontroller first. On. Power, oops. Power. Power keeps slipping off because my grabbies are a little old. There we go. Okay, so now let's probe just at pin 1 here. Is it actually intermittent, or is that my bad probing? It seems like it's actually intermittent, which does kind of speak to like problems on the 5-volt rail, right? Maybe. All right, let's turn this off for a second and think. Let's scope the 5-volt rail here. I'm gonna turn my timing up on that channel. Turn the power back on. And we're going to use our cursors. Huh. Vmax is, so you probably can't see on the display here, but I have basically the ability to measure voltages here. Max voltage on that is it's almost 7 volts. And it gets as low as 3 volts. It's really thrashing. Is this heating up again? Yeah, oh yeah, oh yeah. Whew. Well, Nate says all versions will be doing a light show in the background with version 093 ballyhoos and darkness until it bursts into flames. Currently, that's what it's looking like. Like something is not right. Something is quite wrong. And so okay, so here's a new theory of what's happening. Like an explanation of the symptoms, if not why. And I'll tell you why I think it, and then you can tell me why I am wrong. So let me turn on power here. I'm going to probe pin 1 here, which should just have a constant, 10% duty cycle PWM signal. All right, turn that on. Oh, I actually attach it to power. Jesus, hang on. I have these little tiny grabbies for my power supply, which are great, except when they start to sort of like bend out of shape like this, and then they're not grabbies, they're just stickies. And not in the good kind of sticky, in that they stick to things, in the kind of like they're just a stick. But I've got to bend them back over every once in a while so that I can actually clip them onto a wire and provide power. All right, there we go. Turn this on, probe the pin, and what I'm seeing is like I get a little bit of PWM and then I get nothing. Let me turn that time signature back up. Yeah, it's like the microcontroller is powering up, doing the thing for a while, and then shutting down. And if that's what was happening, that would sort of explain the behavior we're seeing with the actual lights, because the servos, right, they only need to see their own sort of, PWM-ish servo control signal for a short amount of time to set their position, and then they'll stay there, right? And absent any other signal, they'll lock in place. So the servos could be behaving as intended, right? They're getting that, 20 milliseconds of correct signal, and they go to their position, and then the Arduino resets, just as Chris said, the Arduino resets or drops out, but that's fine. The servo stays in place, and the Arduino wakes up a fraction of a second later and restarts its except it's not entirely shutting down, because the position of the ballyhoo itself, as it's tilting around like that, is dependent on the runtime since the last time the Arduino has reset. So it's like some of the accessories are browning out. And this could also explain why why we were getting the weird sound from one of the servos, right? And maybe why those servos were getting hot is it's running at higher than 5 volts. What if I just have a super dirty power rail and I'm just thrashing these controllers and these servos? And again, I would ask, if that's the case, why didn't we see it in version 091? But wouldn't that be interesting? We tried pulling the regulator off and checking it's on its own. Have not yet. Not a crazy thing. But I'd be game. Turn the soldering iron on this time. I have some solder wick. I don't have a solder sucker readily at hand, I don't think. This is like the one time I actually would use a solder sucker. But I think I can just yank it off. Here, let me get my PCB vise back out. Here we go. Just feeding 5 volts directly. Yeah, I can dig that. I don't know how many people read chat while watching these things. Kenneth is saying, pull the regulator off, test the regulator, and while it's off, just squirt 5 volts directly into the board and see if you get the same behavior, which I like. Chris says, I did rip up some power when changing connectors. I did, but really only on the high voltage side, right? Only on the 24 volt side. Everything on the 5 volt side should be basically the same. So let's get this regulator off of here. Let's see. Not gonna be a great. It's not really probably the problem with this this board. It's got it's relatively easy to hold, but it's got enough chonky things on it that's doesn't go. Oh, that's actually, I take it back. That's fine. It goes in the vise. Fine is what I was going to say, and no one can prove otherwise. So I think I can just. Yeah, there we go. So that's our regulator. Check that out in a sec. So while we've got this here, let's look at the board first, and then we'll pull out a breadboard and take a look at the regulator. And that's just me hedging that's what the issue is. All right, hey, hang on. You gotta go back in timeout again, because I'm back in Wiretown, but not for long. Let us just tack a couple of wires into. Literally, I'm going to go into the spots where that regulator was in the board, because there it's a through-hole part, so that'll be really easy. And then I will just shoot 5 volts into the board and see what happens. I guess the AL8860 is being driven off of the raw line, off of the higher voltage line, so it's possible I will need to inject it, depending on what we end up determining the issue might be. If we don't see an issue on the 5 volt rail, I may have to put 5 volts and 14 volts in at the same time to get the symptoms, but I only have the one bench power supply, but we'll cross that bridge when we come to it. I'm sure I have lots of ways of making 5 volts around here, so that shouldn't be too much of an issue. I'm just going to use a little bit of this solder braid just to clear those holes a little bit. Ooh, Palmer says I ordered a Solve-the-Pult solder suckers from Amazon. It's much cheaper than much nicer than the cheap suckers from Edson. 20 bucks. Ooh, I would pay 20 bucks for a decent solder sucker. Similarly, Palmer, I have only ever used the like really dirt cheapy ones. All right, so that's our 5-volt rail. I didn't get that ground hole clear, but I'll get to that in a second here. Kenneth? Kenneth, you don't get your comments read on stream because you know why. All right, there's our 5 volts. Just knock that off, right, don't I? Snip off a little bit of this braid. Get that back in there. When we go to the full production line setup, we'll make a little 3D printed holder for these boards that'll make life a little easier, but let's see. Yeah, this is going to be a pain. So that's also, it's a ground pad, right? So it's got a ton of thermal mass, even with tenting. But I think I can probably just use this like a... There we go. Stab that through. There was a bunch of solder left in that through hole. I just sort of melted it and stabbed the wire through while it was melted. So that'll work well enough. Easier to hold the board in the vise 90 degrees rotated. I don't think so, because this inductor gets in the way quite a bit, and the Max chip as well. But this'll work for now. All right, so let's get the vise back out of the way. Let's see. What was I doing? Power. I'm gonna hook up 5 volts. This actually will be interesting. Once I have 5 volts directly from my bench power supply, I can see how much current it thinks the board is drawing at 5 volts, which actually would be a really interesting thing to know. But before I hook it up, I should set the power supply to 5 volts. Thank you, Kenneth. Thank you. Good. Yes, we're on the same page. Set that down to 5 volts. Yes. Palmer says the Solve-the-Pult is bigger and doesn't get clogged. That's quite good. All right, turn the power supply off. If I remember to turn it on, yes, it's... All right, so there's that. That's set to 5 volts. All right, let's see. I don't know where my current limit is. So this thinks I'm pulling less than 10 milliamps at 5 volts, which is about right, because it's really only the AT Mega running. I guess the Max is in theory pulling some current, but if it's not receiving or transmitting any signal, I don't know that it actually pulls very much current at all. So it's not pulling like hundreds of milliamps, which is what I was afraid of. And nothing else in this board is getting hot, so that's quite good. Which kind of leaves us with this regulator. When one question I have is, does this regulator have like a minimum load to be consistent? But given its highly inexpensive provenance, I don't think that's a question that I can really determine a genuine answer to by Googling, so we might have to do it experimentally. But let me grab, next question, 24 volts on the input rail. Oh, I guess that's fair, Kenneth. I could put 24 volts on the input rail, and I would just be running the AL8860 with nothing else, right? Because there will be nothing powering the microcontroller or the Max, and so that AL8860 should be essentially off. Right, here, I can do this. Yeah, I am pulling no current, less than 10 milliamps of current at 24 volts, right? Whatever the... Oh, 24 volts and 5 volts at the same time. I understand. Yes, that will be interesting. Yes, sure. Let's do that. This will be kind of convenient. I was just doing what might generously be called some cleaning of the workshop today, and found the a giant, most complete starter kit that I was gifted, I think, by my in-laws at one point, which has like one of everything. But one of the things it has in it that I don't have anywhere else actually is one of these little like power your breadboard from a wall wart kind of power supplies, which I think will be an easy, convenient way for me to generate 5 volts. Just that happens to be here at hand because, like I say, I only have a single bench power supply. Chris says USB. Yeah, could certainly do it off of USB as well. I have some adjustable I have a 5 and 12 volt power supply source up here. It's just not really set up very well. It's one of those ones that's like fed off of an old ATX power supply, like a computer power supply, and it basically breaks that out to a bunch of pins. Let's see. What is going on here? So that plugs into power. Those are our regulators. These are just power pins. What are these? What are those pins for? Plus, minus, plus, minus. So, I mean, it must go just like so. I guess we'll double check this before we actually power it up, but that would probably be a good thing to do anyway. Let me grab a power brick, beer break for everybody else, beer break for me when I come back, and I'll plug this into 5 volts and we will get this going. Some of y'all will remember the days when I had a wireless lav that I would use on these streams so that I could like walk around the room even without headphones and could still keep talking. But the sound quality from that was just kind of atrocious, so I have stopped. There we go. See, not as much smoke as there could be. I guess we should verify that that's putting out the voltages that I think it is. I also don't know how much current this thing will really supply. 5 volts, great. Let's see. Nate recommends the kit. Yeah, Palmer Kenneth, I think, can post links. Rubber-coated mail bag can demo the solder sucker. Kenneth, you want to do us a solid and find us that that link? All right, so that's my 5 volts. So that's going to power this, and my power supply will do 24 volts. Okay, so let's get that set up. So I'll unplug that. Need a bit of extra wire. Let's see. I should have made these supply wires on the board here a little bit longer. I guess you don't need to see the entirety of the desk, but that's okay. Just snuggle that circuit board right up to the breadboard there. Turn that off. So that'll be my 5 volts. This is the kind of bodging that happens. Check the power before using it. So this was outputting 5.06 volts or so. So that I'm feeling okay about. I don't know that it's great, and I don't know how much it's going to actually want to supply, but we'll find out. We'll double check that our power supply over here is set to some more volts. Power that up, and we have our indicator light there. I might have a resonance issue. I don't know. Hang on. I need a music mute button. Let me mute the... I don't know how many of you can even hear the cool tunes or if they're really just for me, but when I when I power up the board with the, 12 volts and change, something is like resonating on the board and not in the way that I think is good. I don't know if you can hear that. Here, hang on. I'll get the mic real close. Super weird, right? Huh. And still LED no turn on. Added a tiny buzzer to tell where the problem is. Oh, so this is interesting. So how can I show you this? So here, I'll come back to what was the oscilloscope view. That's my bench power supply. Look at how the power usage is fluctuating. So what does this mean, that whatever is causing the... but that could be because the Arduino the AT Mega is browning out, right, and stopping that PWM, and so the AL8860 is no longer trying to output. Yes, Palmer. Yes, it is getting hot. It's getting very hot. Beans. Okay, so now, this time with caution, what's getting hot? Woof. I mean, give the people what they want, but Jesus. I think it's is it the AT Mega itself? Well, it's cooled down now, but something in there was screamingly hot. Yes, and Kenneth, you're totally right. Something I thought when I was looking for heat earlier, this was definitely hot. Maybe because the entire freaking board was hot. But this may or may not have been the culprit, or maybe that's two related issues. I thought when I was so recklessly touching things just there. Oh, here's another data point. This is now cooled down. My 24 volts is off. My 5 volts is still on. So whatever's causing heat, I think is related to the 24 volt side of things, which is not very much. So I think what I'm going to do is turn the 24 volts back on and see if it really was this AL80, the 18 Mega that was getting hot. Can we still talk to that Mega? Let's see in just a second here. Let me turn that power back on. Yeah, 24 volts on the AVR would make it real dead. Ooh, the AL8860 is what's hot. Yeah, the AL8860 over here is screaming, is getting a real hot real fast. And it was just carryovers, bleed through heat into here. Let's see if we can still talk to it just for interest's sake. Let me just disconnect both of these power supplies just for the moment. And then we can go down and figure out what the hell... okay, so here's a thought. So if this AL8860, if something is wrong and this is thrashing, right, and that's whatever was happening there was causing disruptions in the 24 volt line feeding this, that could cause it to be running less efficiently and therefore generating heat, and also be causing the 5 volt rail to brown out. This seems like a plausible theory. Yeah? Let's see if we can talk to the Arduino. Ooh. Let's see. I'm just going to try and re-upload the exact same code again. Yeah, talks to it fine. Okay, so that's good. Why would Hey, here's a thought. Let's double check diode. Oh, you can't see my face. I was stroking my chin and giving you a pensive look, but in fact, the oscilloscope was giving you a pensive look. There's my face. Not that my face is the important part, but like, you know, I do like it. It does me well. All right, get back over there. Oh, just moving cameras around. Oh, there's a camera. Okay, let us double check diode polarity. So let's go back to, I should close some windows here, but you know, such is life. So this is the Schottky diode here. Let me zoom you out for context. This is the Schottky diode here that is the feedback diode for the AL8860. So that should be sort of cathode toward the sense resistors, or the current set resistors, I guess we've been calling them. Let's unplug that guy, and let's get a closer look. I think this is correct. It's a little, it doesn't look like there's a printed mark, but there is like a little indentation on this end of the diode, which I believe is correct. Let me get an unpopulated one. That might be a little easier to see. Oh, wow, this is hilarious. So this on the right, of course, is the one I've been working on. This is the unpopulated one. It's like the heat is affecting the labels on them. I don't know if that's a thing, but it's really easy to see on these other unpopulated ones that, yes, the diode is in the correct orientation. This makes me think I've screwed up some of this, some of this AL8860 circuitry, because those AL8860s are thrashing themselves. I'm just looking again to see if I have shorting on those two LED pads and that inductor there. What does it look like on this one? Does it match the direction of the old boards? It does. This is what that old board, because with the tilty obelisk. It does. I've rearranged that circuitry a little bit, but that's the same orientation. What is this? Hang on. He said, showing you nothing. What is this part? C1. The 10 U capacitor. That's just a 10 U capacitor on this 20. That's the raw line, the 24 volt line. Oh, hello. Just have a casual angle. Let me make sure. Let me double check my capacitor voltage rating on this guy, which is C1. Let's go back to our parts here. C1 is this part. We'll go back to LCSC. Just double check that should be a 35 volt capacitor. There's only a couple of caps on the raw line, 25 volts, but fine. I'm mostly running this at like 15-ish volts, no more than 24. So that's a 25 volt cap. That's great. Looking to see if this really is an AL8860, which is a silly thing to have to check, but it seems to be. It's really tiny font, but I believe that really is there. What else has changed in this version? I did change I changed resistors deliberately to reduce the amount of maximum current from. Here, these are our two boards next to each other. But in both of them, that 1206 resistor there is the current set resistor. So that's 100 milliohms versus 200 milliohms, which should reduce the current by about half. It feels like there's probably a schematic error, which I'm so excited to go and chase down with y'all just in a moment here. I think what I'm gonna do, just to prove out this theory one more step, is rerun the actual lights and run them with the cases open and feel the AL8860 in there and see if it is also getting radically hot. If it is, like if we're seeing the same issue on multiple boards, then I think that'll be proof positive that like this is we're close to the issue at least. How do I want to plug this in? Let's just I want to do this just like I did the test earlier, so I'm going to do this with DMX. It's going to take me just a moment to get that set up back as it was. But this is good progress, if not necessarily a proof positive of what the issue is. But I'm hoping that these two I've caught up with what the rest of y'all have been hoping apparently this entire evening. I'm hoping that I stick my finger on a really hot thing in here in about 90 seconds. So you're welcome. All right, so I'm gonna pop this guy open. Let's see. I'm going to reattach our power line to my power injector over here. I'm going to attach the other one. And so this should still ballyhoo. Yep. Pulls a bunch of current intermittently and... Oh! I knew it was going to be hot. And I just a little too long. Well, that's great. That's genuinely, that's great. That's proof positive that the error seems to be consistent, which is good. Hang on, beer break, and then we'll go tracking that issue down wherever it is. Okay, let's see what's happened here. Okay, so here is our one thing, let's see, I don't know if there is a way to open multiple schematics at once in Eagle. I wish there was. This is going to be silly, but I'm going to Google it on stream because it's casual. It's casual Sunday. Boards in Eagle. Lots of feature suggestions. Lots of people asking to do this thing, but no quick answers. Print them as PDF. That's not a bad idea, Chris. I can do that. I want to look at these two side by side. So one thing that was leaping out at me here, and I wanted to see if it was the same in the old one, is look at this ground pin. Look how far from any other ground, like it is grounded to here. Like the ground plane in here. Let's do the fill. Look how long this ground trace has to travel before it gets, and this is all nothing. So all of the current for that LED driver is flowing through this little bit of copper down over here, and that's not great. Let's see what it was in the older schematic, in the older version of the board. I mean, that is on its face not great. Let's see if it's radically worse than the old version. No, look, same issue. Here, this is version 091. And that similarly, that ground is like grounded all the way, has to get all the way over here before it like reaches a proper ground plane, but still like, bad, but not different and bad. Let me see about exporting. I think I can export these as like image files as well, which would be fine. Let's see. Cam, schematic, export. Library, step. Export as a 3D model. That's not quite what I want. Print. Sure. Print to file. Orientation, area full. Scale factor. Make big. Scale it up times 3. Sure. And I guess I want this probably in the ripped up version and with the bottom layer on and with that ground plane off. We might have to come back and do this a couple times, but I think this view, which is just the traces and no ground plane, is going to be the most useful place to start. So let's print that. Sure. All right. And we'll close the schematic and the board. We'll open version 9.3. We'll open the board, and we'll get the same view of this board. We'll get the bottom turned on, and we'll print this out. Quote unquote print. I do have a printer. We could actually just print them, but I feel like doing it on the computer will be a little bit easier to see. Export. Was there an export image that I just made? Oh, there is an export image. Well, there you go. Maybe that's better. Oh, we can just put it on the clipboard. Oh, let's just do that. Because then we can go into everybody's favorite tool. Ooh, tiny. Export image. Let's see. Area full. Let's do 1,000 pixels per inch. It's a clipboard, and it's a little big, but that's all right. Thanks, Chris. Good spotting. Let me go back to version 9.1 board, and we will export image 1,000 to the clipboard, bring it over into MS Paint, and paste it in, and there are our two boards. Okay, so let me label these before I forget which is which, although it's kind of obvious if we're looking at the differences between them. But this is version, oops, that is black on black. Version, nope, that is also black on black. Get out of there. Welcome to our MS Paint stream. This is version 0.9.1. And that should be bigger, sure. That should be bigger, sure. And this over here is version 0.9.3. Okay. Certainly there are. Need bottom layer. Oh, thank you, Chris. Yes, I should get the bottom layer on here. Bottom layer. Export image. Okay. And paste. Could have done this in like Photoshop or something where we could like have layers and things, but all right, version 0.9.1. Okay, so those are our two versions. Oops. Version 0.9.1. 0.1. Okay. Okay. And that is what I want. So, I mean, this is the thing, right? Like, let's zoom in a little here. There's not a whole lot different between these two versions. I have my raw line coming up here. I have my raw line coming up here. I have my sensor. I have this through-hole resistor. But that's not even populated. Like, that shouldn't be changing anything. And other than that, I mean, look how similar these circuits are. I barely had to move anything at all. I had to move this reset resistor here. But that shouldn't have made a difference. Wow. I mean, so here's another possibility. Because with the AL8860 is getting ripping hot. That's not a guess, that's a fact, because it burned my hand. But why is it getting ripping hot? And my thought had been it's a schematic issue, but the schematics are so schematic on the right, not ripping hot. I guess we could plug it in right now and see if it get ripping hot, but I don't think it get ripping hot. Schematic on the left, burn Jeff hand. So, but they're basically the same. They're so similar. Really, the addition of this resistor is the only thing. To be honest, I had been remembering this as a much more significant rework, but the big rework was adding this second footprint. So is it possible that something is damaging, and by something, I think I mean this regulator, this switching regulator, is having a switching regulator powering these AL8860s a bad idea? Like, is something in the assembly process causing damage to the AL8860s that's causing them to heat up? Palmer says, there isn't any continuity between the new resistor pads, is there? I don't think so. We can find out. I'll listen. I love you all very dearly, and I will take literally any suggestions you have for where to go next with all of this. I'm actually... I wish I had like a more precise multimeter, because I don't think I'm going to have continuity, but I should have just a couple hundred milliohms there. You can't see that as I probe those resistors. A couple hundred milliohms. Yeah. I guess I can probe at these two resistor pads here. Yeah, 200 milliohms, give or take the, janky old meter. Not the PF janky old meter, just the regular kind of janky old meter. So one thing we could do is take a brand new one of these boards and just shoot high voltage into it without stuffing this voltage regulator in place. Because this is a kind of maybe a crapshoot, but I feel like there's a possibility. I mean, again, it's not an issue we have seen before on any other boards that have that exact same regulator, but I'm kind of at a loss. So I'm thinking, Palmer's right. I did reroute everything related to the Phoenix connectors. Let's have a look at that area. Palmer, that's a good idea. So here's our old set of connectors. Basically, for those who weren't here a couple weeks ago, basically this was a 4-pin pin header. Here, I can actually show you. So this is the old version of the design that had 4 1-inch pin headers, and this is the new version that we've been working with that has headers for a Phoenix connector. Oh, no. So one thing I was going to say, and maybe I will double check myself as I don't say it, is this is the old version. Let me open up the newest version of the schematic. This is version 0.9.3. Yes, if I rat's nest this, that is ground plane, and that is ground plane. So what I was checking is I had to shave away a little bit of the interior of this hole on those 2 constructed units, just to get these stupid mounting screws to finally fit. But it's ground plane on both sides, and even if I shorted ground to one of these, DMX signal line pins, it wouldn't have caused the issues we're seeing. And it's just ground plane on both sides of that hole. So this is the old version, right, of this connector here, and the new version is very similar. It's just I'm changing connector size, right? So ground, DMX, RS-485 pins, raw voltage in through a diode, raw voltage in through a diode. Again, pretty much the same. Yeah. Goofy one. All right, well, just because it's a thing I can do, and it might give us a data point, I'm going to stuff this circuit board with a Phoenix connector real quick, which is in my PCB connectors box. And before we stuff the regulator in there, we'll shoot 24 volts into it and see what happens. Soldering iron is still on. It's great news. All right, there's one of these. So interestingly, little sidebar, I bought, a couple packs, 10 each of the board mount and the plug for these Phoenix connectors. But just because I was curious, I also bought, we looked at this last time, I also bought a pack of the cheap ones from Amazon, just as are they similar enough? They're exactly the same. I mean, I think they're maybe keyed very slightly differently, but PCB wise, there was like, I wanted to say, like, do I have to spend the $1.60 per connector pair each time, or could I spend $1 per connector pair? And it turns out these will work fine. So I'm going to continue using the DigiKey ones for now because I have them. But like, you know, as a hobby and as a thing made for hobbyists, saving a little bit of money is always nice. So let us solder this guy in place. Oh, this is actually, I think I've said before, this is not where I thought we would necessarily be going this evening, but I think it is valuable. So just to like talk a little bit more abstractly about where this project I think is going next, as I solder, is one of the unsolved problems is addressing for these lights, setting their DMX addresses, which so far has just been a function of hard programming their addresses in using the Arduino IDE, but that's not really sort of as functional as I would like it to be. So the DMX library that I'm already making use of has provision for RDM reception, remote device management reception, which is a sort of industry standard way of communicating configuration data over a DMX 512 line, right? What is not particularly available is the provision for using some kind of small, cheap setup to be a an RDM controller, and that is a functionality I would really like. Like, I'd like to have a little device that I could plug into a light or string of lights and just, not do all of the things that RDM could do, but at the very least could, set the addresses on some lights. And so I think what I thought we might be doing this evening, and of course I was wrong, is messing around with the RDM code to see if we could learn just a little about how it's already functioning, he said as he looks for his nice screwdriver, and starting the barest implements of the framework for an RDM controller code for an Arduino. Which would be quite a code base, but at least we could have gotten started. Where I've just lost, my desk is relatively clean and I've lost a screwdriver. It's okay, I have others, but it's making me a little bit, I'm gonna find it as long as I don't need it anymore. Chris says, is that some vias on the bottom side between those two pins next to V plus and between V plus and the next connector over? Let's take a look, Chris. Sorry, let me just finish loosening up this Phoenix connector. Let's see, you were saying some vias on the bottom side between those two pins. So these two pins here, I think you're referring to, next to V plus, yeah, so these two, so those are just some ground plane stitching, just so the ground plane is a little bit more contiguous. So that shouldn't make much of a difference. What's your impulse there, Chris? I maybe am not understanding, and you may be onto something. Let's see. I'm gonna shove a couple wires into. Listen, 0.9.3 a success because Phoenix terminals. That's my takeaway. 0.9.3 not as great of a light because it doesn't light, but okay. So brand new board right out of the pack. No components stuffed except for the connector. Wondering if there's a short. Yeah, anything that we like clearance issues could certainly be behind this. Like there might be layout issues that are causing like current to be where it shouldn't be. That is totally a valid thought. So what I am interested to see. So let's see some confounding factors here. So what's different about this setup from what we've already done? There's no regulator here, and because there's no code on this AT Mega yet, the pin on the AL8860 should be pulled to ground by that pull-down resistor, and so it shouldn't be on at all. It shouldn't be. So we're gonna learn what happens, and I'm gonna very carefully touch it. You know what I'm gonna do? I have a flux pen here. It sizzles a little bit when it touches something quite hot, and these other units were quite hot. So that's going to be my tester pen to see if it's like ripping hot before I touch it with my finger. All right, ready? Here we go. We are drawing no current. And that flux is not immediately melting away, which is good. And that's cold. Okay, so that's a data point. So there's nothing in... Should be writing things down. There's nothing in the circuit as wired, without the regulator in place at least, that is causing this to heat up, which is good. That's a good sign. So now, do I put... Maybe... Hang on. Let me just... Because it's going to be fast and easy. Where's that regulator I was waving around as if it was a criminal earlier? Here we go. I'm just going to wire some volts straight to this guy and see what we get as an output. Where's that multimeter? Here we go. All right, so there's, wow, just like all up in my business there, Mr. Camera. All right, so there's that. I should probably do this with a breadboard. That'll make my life a little less crazy. Okay, so breadboard, gonna need a couple of bits of wire to shove into the breadboard. Ooh, I don't have them close at hand, of course, but I did, you know, I'll grab them, because why not? Hang on. So this was part of my tidying today, was finally sorting out all of my DuPont connectors by what connector types they have on them. And they were for exactly this purpose. Like if I'm gonna do some breadboarding and I know I need a pin-to-pin connector, now I just have a giant bin of them. Of course, does it fit on the mess that is the bench today? No, of course it doesn't, but that is beside the point. So I'm gonna pull a couple of connectors there. So that's going to be my in and my ground, and I'm going to need my out and my other ground. Okay, so ground and out. I'm just curious because of those, you know, weird, well, that is broken. Weird oscilloscope readings. I'm really curious to see what the regulation on these is actually like on a multimeter and then on the scope as well. So let's plug in our high voltage here, and we'll attach this to ground, and we will just hold these here. All right, so that's on, and this is the regulator, remember, just straight off of the board. Four point-ish volts. 4-point-ish volts. You know, plus or minus 5% from 5 volts, which is not great, but like within tolerance. And also, like, remember, crappy meter. So like this could actually be better than it reads because we don't necessarily fully trust that meter. Okay, so regulator seems okay. Regulator seems okay. Board with only Phoenix connector on it seems okay. And under no load, yeah, for sure. We could put some kind of load on it and see if it struggles. Let's see. Here, a little bit of exploration needed, just going up into the bins, looking for my power resistors. Molded chokes, miscellaneous switches, rotary potentiometers. This will be my next ASMR episode, is I'll just quietly read all of the bins that I'm looking at that you can't see. Adjustable inductors, trim pots, knobs, slide pots, Tough One RF modulators. That's from a couple hobbies ago. That was a fun time. Oh, do I just have a USB light or something I could use to put a load on it? Maybe? But not like an easy to attach USB connector. What do I do with my power resistors? He asked the strangers and friends on the internet who aren't allowed to come into his home. Bridge rectifiers, variable caps. Maybe I moved power resistors elsewhere in the workshop and have forgotten about it. I had a... Oh. Wait for it. No, those are relays. Those are not power resistors at all. Well, I mean, here's the truth. Like, I that seems like plausible enough to be... Oh! That's quite warm. Why is that so warm? Under no load. That's quite warm. All right, well, that's an interesting data point. I feel like all of my data points this evening have come from, like, personal injury. I'm a little... I'd like to, like, learn something from keen insight and technical know-how, and not because it's hot. No, I'm having a great time. It's just weird, right? I'm not crazy. This is weird. I mean, I might be crazy, but it's also weird. All right, so here's a new regulator fresh out of the package. Let's see if it does the same thing. Power on. So interestingly, I noticed before I turned off old Hot Boy just there a moment ago, that bad regulator, it was pulling about 40 milliamps of current at 16 volts on my power supply. This one, 0 amps, and we're much closer to 5 volts. Might be warm because of... yeah, I mean, the awful parts are certainly a potential culprit here. So this one, pulling no current now and 5 volts right on the money. I'm struggling to put together a theory of how this all relates. The AL8860 getting hot, the voltage regulator being crap. Like what I'm trying to come up with a scenario for like what could have failed first and therefore caused the rest of this. Like if the regulator, what I'm struggling with is the regulator and the AL8860 are basically the only things that touch the raw voltage line, right? That 24 volts nominal we've been talking about. But they're really both just drawing power from it. They don't really interact with each other in any other way. Like, is it feasible? I mean, maybe my issue is just regulation on that raw voltage line, right? And having a switch mode, power supply and a switching regulator on the same line is I just need more bypassing, maybe. And that they're oscillating with each other or behaving very poorly. Does only brown after that's a good question. So maybe we whip together, maybe we complete building this other board real quick, don't turn the LEDs on ever, and just look at, or maybe we don't even plug the LEDs in and just look at what happens. I'm game. That's a great idea. Let's see. What else? As long as we're building one from scratch, before I plug the regulator in, I'm going to put the programming headers on and talk to the microcontroller and see if anything gets hot. nothing should, but like also, but I guess none of should have should in this case. Let's see, just rooting through my bin O through-hole headers here. Compare current draw before and after LED introduction. Yeah, that's a good idea. Just look at the current in between both. What could have been making the servo hot? I do think that whatever was going wrong in the regulator was causing that output to sometimes be as high as 7 volts. And those servos, I think nominally, you can run them at like, I've seen this in the model plane community. You can run them a little bit higher than 5 volts, and you can run them up to like 6, and they have additional torque. So some people do run them that high. But I wouldn't be surprised if a byproduct of that was additional heat. But that's, I think, all related to the idea of, and I think that's all related to the idea that the regulator, as we've seen, our what I've been calling Mr. Hotboy over here, our bad regulator was bad in some way, or was made to fail. By either failed us or was made to fail by something else. Where's my little spare ISP cable? There we go. And my header. Yeah, so Palmer, I think that the hot servos maybe were related. To our ongoing power issues. Let's get this down in there. Do a slightly better job soldering these this time. Seems like not a bad idea. Okay. And before we do anything else, let us just say hi to the microcontroller. And let us not put any code that would turn the LED on it. In fact, let us literally just burn the bootloader and an empty sketch. That seems fine. So into the programming cable we go. We will probably need to reset this guy. And burn bootloader. Writing, reading, complete, and upload. Okay, so that's done. And this is just being powered, the 5-volt rail is just being powered by the ISP header at this point. So let's just take a little feel around. Use our Is It Screaming Hot pen. Doesn't seem to be. Let's wipe some of that extra flux off there. Okay, well that's a good sign. So now what? Now we put the new well-working regulator in and see what happens. Because I was just running the 5-volt line. I guess we could try putting more, like, I can't imagine this will supply more than like 100 milliamps. We could give more current availability to the 5-volt line, and see if that changes anything. I don't hate that, and that's relatively easy. I can use the points where the servos would connect, because those have a ground and a 5-volt connection point each, and it won't get in our way later. Just because, like, if there's a problem with the 5-volt line, but it's being masked because my programmer can only supply a little bit of current, that seems like an easy thing to eliminate. I don't expect this to change anything, but might as well find out. So that's our ground. That's our 5-volt line. Tack those in real quick. I was just struck by the strongest feeling. Do you know the term rubber duck debugging? which is an idea from software coding idea from software development where you just, to help you solve problems, you just keep a rubber duck nearby, and you talk to it and you explain your problem, and the process of talking it out helps you figure out what the problem is. Basically, this evening, sometimes it feels like a rubber duck, but often it feels like I have the world, like, I don't know. Thank you. What I'm saying is thank you for all your help this evening. I'd be totally lost for what to do next without y'all. I didn't mean to compare you to ducks. So I'm gonna shoot 5 volts into this thing. Yeah, Chris, I realized about halfway through it's not the most flattering metaphor, but I do like ducks, so that's nice. All right, so gonna hook up 5 volts directly and just see what happens. I'm pulling less than 10 milliamps at 5 volts, and our better a duck than a turkey. So nothing is screaming hot. Nothing is even warm. Okay. I do have a built-in LED on this board as well that I could use to like show us some state of the microcontroller if we wanted to, if that would be helpful. But no, nothing there on 5 volt line, so that's good. So I think the next step is put the regulator in. AL8860 should still be off, and see what happens, yeah? If this goes bad, I mean, this was solder this connector and those 2 headers on. This would not be a hard place to get back to if we want to do this again and do something else at this phase. So I think I'm just going to plow on. Okay, so that's the regulator soldered in place. Kind of poorly, but so be it. In, ground, out. Yes, that's correct. Okay, so now we shoot high voltage and or higher voltage into it and see what happens. I think there's nothing else for it. My body is having like a fear of getting burned. Any reason to run the full code before the regulator? I don't think so. I don't think so, Palmer. But help me out. Put that in your pocket, and when I get stuck when this goes badly, remind me that that's an option. Yeah. So no LED attached. That's one difference from our previous test, right? This, I just went ahead and whacked an LED on there, right? This does not have that. So this will be another data point. Okay. All right, we're powered on. We are drawing less than 10 milliamps at 13 volts. Our sizzle stick indicator is not sizzling. And no appreciable amount of heat. On the board, no appreciable heat on the regulator either. Yeah, nothing. Interesting. Is that true? I mean, I guess maybe a little bit, but not anywhere near screaming hot like it was previously. I will leave that powered on for a second here. Well, let's run a little bit of code. I do have like on a separate data line. What is it? D11. I just have a green LED just for exactly this kind of like troubleshooting. So let's write a little blink sketch and just blink that LED so we can tell that things are still running. So pin mode 11 output, digital write 11 high, delay 500 milliseconds, digital write 11 low, and delay 500 milliseconds. We'll plug our programmer back in, power cycle it, and upload. Yeah, there we go. All right, so now when I power this up, just this will help us, like, it is powered and the board is, you know, if this were browning out like we were seeing before, I feel like with a half, you know, a 1 hertz cycle, we could see it stuttering a little bit more, but that seems to the naked eye pretty spot on. You know, it doesn't seem to be flailing. And again, I mean, yeah, maybe slightly above room temperature, but not significantly. So here's the thought. So there are some order of operations differences, but some differences between this test that we put together earlier in the night and this test is this has an LED on it. And this doesn't. And what I'm wondering is if the LED was installed backwards, and this one was not, because we proved that it was not. We lit up the LED in the correct orientation. We used our power supply to do that. Like, is there some way that attaching an LED to this could cause the start of the damage? I mean, let's probe around for Jeff sadness on this board just to see. But yeah, this is all going to be cool. Yeah, cool to the touch. So for some reason, it's the addition of the LED that maybe is the point at which things start to fail, possibly. So, I think, he said very slowly and cautiously, we get another LED out. Is there an option to install a small test LED like the one from our kits? Like a little generic, like 5mm LED, Chris, I think you're saying? We could. The problem is the scale on this is 0 to 500 milliamps now. And those LEDs typically have a limit of 20 milliamps. And you can't put an additional current limiting resistor in them because it's a part of the buck converter itself. So we could, but if we ever ran it above like 4%, we'd cook the LED. And I'm afraid that in the startup cycle of things, like it might flash too high of a current for too long to cook an LED, and we wouldn't learn anything. What I think I'd like to do, just because I don't mind destroying things in the name of science, I'm going to take another LED, we're going to ring it out, we're going to confirm its polarity. The LED 860, I'm also pretty sure, sidebar, has short circuit protection on the output. So if you have your LED lines and you short them, because it's meant to go in like industrial flashlights and light fixtures and things, that should cause it to just shut down. It should be able to sense that and shut down. So like a shorted LED wouldn't be an issue. I don't know if you have a reversed LED, if that would cause problems, but I can't imagine it would be significant. And this is still, yeah, a few degrees. Can you meter the pins of the LED on the board before adding LED? I can. I don't think it's going to really show anything. No, Chris, I don't think so, because again, because of this clever chip puts that, you know, the LED itself, which is represented by those pads again, is part of the circuit. So if there's no diode there, the circuit isn't doing anything, so to speak, or shouldn't be. I think I've prevaricated enough. I'm gonna just we're gonna put an LED in here and see what happens. Now, because that pin on the Arduino is not, have I tested just the LED from the last board? No, that's a fair question, Chris. I could do that. Turn the soldering iron back on. hydration break. While that's heating up, let me grab yet another LED. I'm not going to put a heatsink on it this time because we're not going to bother trying to preserve it until we know it works. Where are... And I was looking... So I have 2 different color temperatures of LEDs in this project. I have some like 2700 Kelvin and some 5000 Kelvin. The lights from earlier in the night, you can actually, I think you can see, I can see the difference. I think you can too. See how this one is slightly warmer looking and this one is slightly greener looking in those lenses? That's our warm white, that's our cool white. So we have one of each. This board from earlier is cool white. This next LED will be warm white. So I don't think it's a color specific issue, because we had that same problem with 2 different colors of LEDs right off the bat earlier tonight. But could be. All right, so there's our new LED. We'll turn our current limit way down, and we'll hook up that, and we'll just turn our current limit up a little bit. There we go. So that is the correct polarity, which is good. So Past Jeff got it right. And I guess I'll confirm that the pads on the board are labeled correctly. That doesn't seem to be a crazy thing. So let's see. The pad labeled plus is connected to the pin 2, the set pin of the AL8850. And pin... oh, no, that's pin 4, the set pin. So yes, pin 4. Well, at least it matches what I said in the data sheet should be the plus sign. Or in the schematic there. Let's go pull the data sheet real quick. AL8860. Yes, I've viewed this data sheet a lot. Okay, here's our circuit. So the, okay, that's interesting. This says the cathode side should be connected to that set pin, or the anode side. Oh no, that's correct. Yes, the positive connection to the LED should be connected to pin 4. No, that is accurate. So the side labeled plus on the LEDs. Let's just double check. Yeah, set. Yeah, you can see I basically laid out the schematic to match the data sheet there. If I sort of flash between them, you can see how those mirror each other. So plus and then minus would be connected to the inductor. Let's see. Chris has a question. Is your cable marked for plus and minus correctly? Yeah, so Past Me labeled the positive wires with a black Sharpie mark on this brown cable. So that is my positive connection there. Which is not, I mean, it's correct in the sense that it seems to have been consistent. It is not correct in any other sense. All right, so I'm going to carefully feed that through. Yeah, if this... I'm not going to finish that sentence. I didn't mean to call you ducks. You're all wonderful people. You're all great. None of you are duck. Well, one of you is a duck, but you can fight amongst yourselves for who that is. No, you are not ducks. You are all tremendous, wonderful, helpful nerds, and I appreciate it. Yeah. Just duck out, Chris. Chris. Killing me. Okay, let's trim this flat. Ducks fly together. I mean, listen. The following is a sentence that I'm going to say. Even if you were ducks, I would still appreciate having you here. Okay, so now, having soldered that LED in place, having confirmed its polarity, having made sure nothing's shorting on the board, I'm going to plug this back into my higher voltage power. And the LED should not come on because the control line on the AL8860 is still pulled to ground and there's nothing on the Arduino that should be pulling it high. So in theory, we should see our blinking LED. The blinking green LED, the large LED should not turn on. Let me adjust my current limit here before I start and just double check my voltage. Yeah. Okay. Just do this live. All right. Big LED does not turn on. Green LED blinks. Let's check for heat. No heat. Nothing significant. No significant current draw on the power supply. No heat on the voltage regulator. Okay. Things are still behaving for the time being. I think, and open to suggestions, I think the next step is to have the Arduino turn the LED on and see what happens, yeah? Just a little bit. We'll start coding that up, but like I say, welcome to anything else anyone thinks is a good idea. So here's what I think. I think we should just, we'll leave the blink going. We'll say pin mode 3 is an output. When this boots up, wait half a second. Analog right pin 3. 05, so a very low, just a little glow. Wait a quarter of a second and turn it off. And then it will start blinking our indicator LED. So it's only going to turn on for a quarter of a second and then turn off. Let's make it maybe just a little bit brighter so we can see it. Just because I'm afraid. Yeah, Chris, like 1%. Yeah, we can start very, very low. At some point, I won't be able to see it with my human eyes, but I think that'll still be visible. So let's unplug this from power, plug our programmer back in. I don't strictly need to like unplug it from power before plugging in the programmer, but it feels like a safe thing to do, especially because the programmer is hooked up to my expensive computer. All right, so unplug that. Oh, here's a thing we could do. Before we plug it back into high voltage, let's plug it back into 5 volts. Now, so we won't be driving... Right? Is that a safe thing to do? If I just put 5 volts on the output of my regulator, am I going to cause it issues? I don't think so. But one way to find out, we have lots of regulators and they're very cheap. Let's turn the power supply down to 5 volts. And this, I'm genuinely having an incredibly stimulating time doing this. I wish this was working, but like so rarely I feel like do I get the joy of like just going deep down this weird rabbit hole, and this is so I'm having a great time. I'm having a great time. Gosh darn it. Okay, so what I'm trying to ascertain is if I don't put anything on the input and I just put 5 volts on the output of this converter, is that going to make it very sad? No current drawn. Oh, I guess I could show you. Doesn't seem to be getting hot, so I think this is fine. I mean, it should be fine, but it's a who can say. But that seems like a fair enough test. Okay, regulator seems to be happy if I just bypass it and put 5 volts in. So let me double check. 5 volts, yes. Yes. Okay. So let me now. So the Arduino will be running code that tells the AL8860 to turn on, but the LED voltage, the higher voltage, is not present yet. So let's turn the power supply on. Our bubble sauce is not bubbling. And we're basically still cool to the touch. Okay. Well, and this, one of the nice things about those other AL8860s, like, you know, burning me, is they got real hot real fast. So I don't feel like we need to leave these sitting here for, you know, a minute waiting for them to heat up. I feel like we're pretty good. Yeah, no kidding, Chris. All right, so I'm gonna set my power supply to the, you know, 14, 15 volts we've been working with, turn it off, hook things up. So again, what we're hoping to see is power on, this turns on for a quarter of a second, and then the green LED will resume its 1 hertz blink, and nothing catches on fire or burns me. That maybe should be first. That's goal number 1. But, all right, here we go. Power. Ah, I did not see that turn on at all. Let's try that again. Interesting. Let's just, for gits and shiggles, let's just increase what it means to be at a low level. So that'll be about 10%. That's, I think, the level we were testing with before. All right, let's upload that. All right, pull that. All right, one more time. So again, oops, show the table so we can all celebrate together. Power on. Nothing. All right. Well, just in case it's some weird startup effect, let us wait 2 seconds after power on, and we will digital write pin 11 high, digital write pin 11 low, analog write, and delay 1. So now that green LED will blink on for a quarter of a second when the big LED should be turning on, just to give us a little bit more positive indication when that should be happening. Because right now it's just before the LED starts blinking, and I feel like we can do a little bit better than that. All right, so new code is uploaded. Pull that. All right. So again, one more time. So we should see power, wait 2 seconds, a little short blink of this, and then up 1 second pause, and then this should continue blinking. The green should continue blinking. Nothing. I am so flummoxed. What is happening? This is a doozy, friends. This is a doozy. Pull one of our friends from last time. Pull this guy who didn't work. Check VF on the LEDs. I sure can. I mean, they're currently off. But I could leave them on for longer. I just worry that things are going to get hot again. We're also not necessarily going to see a voltage, right? Because it's a buck converter, but we would see things happening, I suppose. What I was gonna look at just real quickly there before we jump in, that's a good suggestion. Is this the first iteration where I've used this TSOT 25 pin? And I don't think so. I thought that's what I was using for a long time. But the last 2 iterations have used the big 8-pin MSSOP. Where would my older versions be? Let me stand by. Hello! I meant to do that. I didn't just bump the Stream Deck with my headphones. So I was gonna pull, I just can't remember anything now. I was gonna pull some of my older versions and look at the board and see what I was using. So this one's, oh no, this one's using a TSOT. This one's using the little 5-pin package. That was the version, I don't know, 8.1, I think. And this guy was hand soldered and TSOT. Yeah, okay. So this is not the first time I've used that chip. So that's comforting. I'm just so all right, here's a thought, and I do want to take the suggestion of putting a meter or a scope on those LED output pins, but just double checking. So the previous iteration of the board, sorry, just looking at a data sheet there. This is the previous iteration of the board had an AL8861, I'm noticing, as this MSSOP part, but that's just the the automotive spec version of the 8860. So I don't think that's what's making a difference. Yeah, let's set this LED to run a little longer, and scope it and see what's happening. Yeah, I like that. I'm flummoxed. This is a working circuit, except that it's not. I mean, if I'm indignant enough, it will just start working. But we know that's not how things work. All right, so let us instead, let's make this run for 10 seconds each time we boot up, just so it's not running forever, and possibly, let's do 5 seconds each time we start up, and we'll have it synced with that green LED still, just because I think that's making things a little easier to see when that LED should be turning on. All right, so that's plugged in. Oop. And upload. Very good. So let's get set up. I think the meter is what I'm gonna. Hello. I think the meter is what I'm. Oh, my camera has frozen. Ah, has this camera frozen? No. Hello. But this camera has. That's bizarre. Well, my hands haven't, but at least to me, it looks like my face. I'm just constantly looking at something very interesting in the lower right-hand corner of the screen. What I might be looking at is my Twitter handle, @JeffersGlass. Shameless plug, I guess? It's not much of a plug. Let me just... There we go. Hi! Of course, I'm blue because Logitech drivers suck, but that's all right. I can fix that. Welcome. Ah, there we go. Ah. Ah. Much better. Okay, hello again. Let's get set up to scope this guy and see what happens. So, I'm gonna put this on. I think I want to do. So, are either of these? Let me take it back to the computer. Are either of these pins grounded? They are not. So I really do want to probe between the pins of the LED, huh? But that's going to be a real... well, I was going to say it's going to be a real bummer, except maybe I can just strip off a little bit of wire from the LED wires themselves. Here, I need the oldest of wire stripping tools, a single-edged razor blade, which I bought a box of at Harbor Freight like 6 years ago, and I'm almost done with. It's like finishing a roll of solder. Like, well, this is going great, huh? Here, let's see, give that a little more purchase on here. Now that I've got a little strip back, I'm wondering if the wire strippers... There we go. That's what I was hoping would happen. And now, just burn the coating off? Yeah, I certainly could. I have a lighter nearby here somewhere. But this seems to be working all right. Making a little nick and then coming in with the strippers. And... I can tell that Kenneth has left us because I said coming in with the strippers and he didn't say anything. So I assume he's gone for the night. Kenneth and I go back almost 20 years. And people don't change. Kenneth, if you're there, you're great. All right, so I'm now set up to probe across the pins of the LED. Let's get you set up for oscilloscope view. All right, so that's this view, which kind of works. Yeah, it works all right. So there's that. I'm going to want this to be like 5 volts per division. I don't recall what the frequency that we're operating at is, so let's go 1 millisecond per division. And we'll just see what happens. So I'm still set up for high voltage on my power supply. Yeah, here we go. Oh. Interesting. I don't know if anyone saw that. The LED, it might be just off camera, the LED turned on for just a hot second and then did not turn on again. But I am seeing that, like, that interesting waveform there. We might see if that correlates to anything. Oh, although I'm not applying power. That might just be, like, because this is acting like an antenna. Although that's 5 volts. Chris, that would be what the code tells us to do, except there's no power in this thing. There's literally, I mean, I'm holding the power lead in my hand. What is it measuring? I don't know. I mean, it might be confusing things because the ground lead on this probably is genuinely connected to earth ground. Let's check our burniness. Oh, I see smoke. I thought I did. Oh, maybe it was the reflection. Don't get too excited. Oh, wait, hang on. Oh, no. It's not screaming. No, it's not hot. What is happening? I've unhooked the probe. The LED is... It was on for just the briefest of moments, and then nothing. Well, voltage regulator is cold. ALED 860 is cold. At Mega is cold. Oh. Hello. Man. Beer check? Yeah, fair enough. Thank you. Yes. I do need a drink and a pause and a regroup, because I'm now, other than the LED not turning on, which is the whole thing, it's behaving fine. Yeah, Palmer, it's the LED is now turning on for when I power cycle it. The green LED comes on for 5 seconds, and for those 5 seconds, this should be at 25%. I guess I could scope the PWM pin and see if that really is true. Just in time to take you back to oscilloscope cam. I don't know if the oscilloscope cam is strictly necessary, but we've got it. And, you know, I guess the whole point of this is like to try and make things visual. If I don't want to just tell you what I'm doing, like, I don't know, it could be a podcast. All right, so there's, let's see, let's go back to 1 volt per division. We'll go back to 500 microseconds per division, sure. And we'll probe at that convenient via right there. So when I power cycle this, I should see PWM, yes, with about 10% duty cycle, and then it goes away. So that is as designed. It just doesn't turn the LED on. Going back to, I forget who, was it Palmer or Cookie, who suggested testing the LEDs at one point that were on this test or the previous one, which I had not yet done, and I kind of like that idea. Let's start with, I mean, they both don't turn on right now, but let's pull the LED off this board and just hook it back up to the power supply and see if like something that we're doing smoked the LEDs. And normally when you do, especially with these high power ones, you can see it in the LEDs themselves. Like you get a little black dot of charring under the lens, but you know, we're beyond the realm of should. I think I've said like 7 different ways tonight, but it's true. Like, you know, trying to like uncover what assumption that we've made somewhere along the way that is no longer accurate. Turn the current limit down, turn the voltage up, and there we go. Okay, so the LED is still functional. This is the one I just pulled off that just non-working test. Oh, Chrissy, did I test the LED after I put it on the board? So I just pulled that LED off the board to test it again. So I didn't, whatever I was doing didn't fry the LED. Is what I was hoping to learn, which is good. What is this, which one of these is the pull-down resistor? Let me put this LED back in, just now that we know it's still good. Confirm the LED pin's output polarity on the PCB. Yes. We did that in the... So here's our data sheet, and here's their sample diagram. So the anode, the positive side of the LED, should be connected directly to the set pin, and then the negative side, the cathode of the LED, should be connected to the inductor. And that matches what I've drawn in the schematic here, where pin 1 is the anode, kind of the set pin, pin 2 is the cathode. I guess I should double check in the layout one more time. Let's see, preset top. If I come to here, the anode, the positive side is connected directly to the set pin, yes. And then the cathode is connected to the inductor. So yes, that appears to be correct, I think. So I'm going to put this LED back in, and we never resolved, I don't think, because we got distracted by hot things, which, given that it was my fingers, I think that's fine. But we never really resolved the, like, presence or absence of the PWM signal, like, at the Arduino versus at the AL8860, or did we? So we have to probe the LED outputs, says Chris. I mean, that's what I was sort of just doing, and I don't quite understand the results it was giving me, but since I'm not confident that LED was turning on, I think the answer is we were not seeing it turn on. We're not seeing the LED even trying to turn on. Is the chip in the correct orientation on the PCB? Palmer, totally fair question. It is, and you can definitely tell because it's asymmetrical. It's got 2 pins on this side and 3 pins on that side. So no, that's a very valid question, and is something that I have to like double, triple check in the PCB ordering process, because the way that the board houses represent like what rotation means what. Like you basically send them a file that says, hey, I want these parts at these coordinates on the circuit board, and I want them to be placed with this rotation. But what that rotation means is not necessarily standardized across board houses. And like, you know, is 90 degrees of additional rotation clockwise or counterclockwise? So I end up double checking it in their preview service pretty thoroughly. Let's see. Okay, so there's that, and I'm gonna hook this other side of the LED back in. Gonna be a bit of a kludge, but I think when you have a through hole that just like the solder is just stuck in there, sometimes you can just like remelt the solder and shove your new wires through. Well, I may not be as lucky this time. Oh, Chris, so we wouldn't actually see a PWM signal per se. It's not actually doing pulse width modulation to drive the LEDs. It's using them in the feedback path of a buck converter. So we should still see incidental spikes of current followed by times of no current, but it's not, strictly speaking, PWM. Have we determined that the inductor is okay? We have not. It's a fair question. Since I just wired this LED back in, I'm just gonna whack power on here again, see if anything different happens. I don't expect it to. Would help if I turn my current limit up. Oh! Jesus. Well, that was fire. That was fire in a couple different places, too. The AL8860 definitely smoked. It, like, glowed red. There was a second one, and I don't know where it was. But given that this board is going to be officially retired after this, Why don't I just give you a close-up and we'll turn power back on and we'll see what the other thing was that was glowing. Yes, I made you wait over 3 hours, but you true fans, you true ducks, are here for the burnination that you really all came for. All right, shall we? So the AL8860, I mean, look, you can see it's like blistered. I want to, like, something else smoked. Something else smoked. Maybe that will be a clue to what the problem is. It's possible I was just seeing the red LED here. That AL8860 is dead as a doorknob, right? It has stopped burning. The regulator is still working fine because the Arduino is still running. Yeah, maybe I was just seeing the red LED out of the corner of my eye. What in the whole hell? Jesus. What is happening? It's got to be something to do with this, how this TSOT 8860 is wired. I must have the circuit wrong or the schematic wrong or something, because this worked and this didn't, and they're basically the same circuit. All right, let's see here. Let's double check our pinouts and our connections. So on the TSOT version, pin 1, which is down here, is the switch pin. Pin 2 is ground. Pin 3 is control. Opposite control is set. Next to set is raw. All right. And we should have double check our circuit. Chris, oh, hello. My face is over here. Hi. Chris says, watch the replay. Oh my god. The red LED did get a tad brighter as the inductor. Oh, do you mean the other the chip that did? So just the one chip burning. That was the only thing that burned. Which I guess is good. So let's see here. Here's our circuit. So Schottky diode, sense resistor, set switch, ground, control V in. Let's go to our schematic. Set switch, ground, control V in. Palmer says, agreed, I would say the fire came from the pin that's most charred on the side closer to you. Yeah, that makes sense. So that pin, for what it's worth, is the switch pin, which is the part of the pin, here, I think it says in the data sheet, the drain of the ND modulator. So that's the part that's actually passing and controlling the current that's flowing through the device as it's acting as a switch. So that makes some sense that that would burn, if anything was going to burn. Now, nothing should have burned, but here we are. Do I still have my MS Paint? Yeah. It's just wild to me, like, the two circuits between version 9.1 and version 9.3 are, I think we can all agree, the same. I mean, unless we're back... Oh, shit. Look at this. Look at this. Look at this. Hey. Look at this. Look at this through-hole pad. That through-hole pad goes all the way through the board and would be shorting out the switch line. Is that really true? And the DRC didn't catch it? Show me everything. Show me the whole board, Eagle. This is the current version. Look at that. Oh, look at that. You guys, you nerds, look at this. Why was this not caught? Or was it caught and I just ignored it because I was dumb? What's our 1 Oh, look at our... Oh. Oh, hello. Hello. That would explain a lot, wouldn't it? Things acting like a dead short? Oh, yeah. So I, like a fool, ignored my design rules check because I was just looking at the top here. I said, man, somebody roll back like an hour when I was going through a DRC and I was like, well, this is weird. It's overlapping with nothing. I'm going to ignore that. But if I look at the bottom layer, thanks, Eagle, it's overlapping. So that would short 24 volts directly onto the switch pin. And that would be bad. That'd be very bad. Wow. Cookie, the model of the chip is the AL8860. Here, I show you. AL from Diodes Incorporated. The AL, oh, you can't see. AL8860 or the AL8861. One is the AL8861 is like the automotive compliant version, same chip. Yeah, no, Chris, I did zoom in. What I didn't do was enable the right layer, right? So I was looking at, because almost everything of interest to me is happening on the top layer, I ran a DRC, I was looking here, and there was one, so wire stubs don't mean anything. You probably can't see, but this is the wire stub error list. The air wire, which is things that aren't routed, is a problem, but I think that's just something that wasn't there before, so I must have just done that. So let's reroute that. Yep. And then there was one overlap error, which means that things that are colliding with each other, and it looked like this. And I was like, oh, that's weird, but this must be some kind of error in Eagle. But if I turn on the bottom layer, there it is. It's colliding with this line on the bottom layer. If I just routed that, around that resistor, I could have saved all these problems. I feel a little dumb for not catching that in the design phase, nor like 70 minutes ago when we were looking at that DRC. On the other hand, I'm still like flush with the enjoyment of the troubleshooting process. So that's good. Yeah. We learned something. We definitely did. Turn on all your layers. Believe the DRC. Eagle's design rules check is to be believed. What I'm wondering now, seeing as it's... yeah, turn all the layers on and believe your design rules check. What I think I would like to do to close this out, because this is one, maybe going on the longest stream I have ever done. Yeah, 094. Thanks, Chris. But thankfully, I'm not going into work tomorrow, so choice. I'm going to, because I think it will take just a few minutes, I'm going to get one of these darn things working. I am going to take the board, I'm going to whack a Phoenix connector on it, and a regulator, and an LED, and I'm going to tell it to glow, and it's gonna glow. And I'm going to go onto the back of the board here. Ooh, you know what? We can see this error with our own human eyes, and it's gonna feel so good. Get in there. I'm gonna file away my errors. So, yeah, there it is. Okay, let me get a pointing stick. So let me get that to focus. Yeah, it's that. So this is the switch trace here, and that is the through-hole resistor. So I'm going to, what am I gonna do? Probably just etch away this trace and then bodge wire across those two vias. I think that'll be easier than trying to like scratch around this thing. In fact, I'm gonna use this one. I'm gonna use this board that I've got right here. Sorry, sacrificial board, but you've been chosen by a jury of your peers to become the working iteration of Demilight 093. All right. No need to show you the up close and personal of filing. I think you all have filed before, I imagine. Maybe not. If you've never filed, you can watch my second channel. Jeff files way too close to the camera on Tumblr. No, Palmer. My poor implementation. Palmer said it was partly his fault because he suggested adding a through-hole resistor so he could mess with the current limits. My poor implementation of your good idea is not your fault. I'm really just gonna obliterate this thing. Okay. No, JLC PCB is a board house. Their job is to, make what you send them. The assembly team will, if they think your part footprint doesn't match what they have, they will confirm that with you. But especially for a real bargain board house, no, that's outside of their purview. Yeah, so that's well and truly scratched away. So now we do a quick bodge wire and like 8 more solder joints, and I'm hoping we can put this thing to bed. File the trace on the other side of the through hole. Yes, thank you very much. I do. Thank you very much. A plus, good catch. More filing. Get that real down in there. Let's see. Not exactly the right tool for the job, but I'm not going to bust out the Dremel to obliterate one trace. Let's test that again. Get the continuity meter back out. Continuity to that via. Nope. Continuity to this via. Nope. Pretty good. All right. I feel okay about that. I mean, I feel it looks awful. I feel awful about that, but just for the satisfaction of getting this to make some light tonight, I feel okay about that. It's not going to be pretty, but if it works, it's going to be satisfying. If it doesn't work, it's going to be crushing. But, we'll learn something else then. Put a little solder on the wire, put a little extra flux on the circuit board. Chris, this whole iteration is not going in a box. It's going, I'm going to throw it into the ocean. I guess I could get the rest of the boards of this iteration working, and then I could, there's enough that I could name each of these lights after one of the people who are still here watching this mayhem. God, that's amazing. Demilight version 0.9.3, now with convenient carrying handle. No, good catch, Cookie. No, this is a brand new out of the box board, as it were. All right, Phoenix connector, regulator, programming header. I'll reuse the LED. Phoenix connector, check. Regulator, let's use a new one, check. Header pins are here. 3 and 6. And an LED that I will salvage in a moment. Okay, let us do this thing. So let's do the header pins first. Not gonna bother to get the vise back out. I'm feeling the winds of hope at my back for the first time in a while tonight. And we're just gonna ride that high for a little while. And I feel okay about that. All right, so let us tack one pin there, get that nice and situated. And then we will do the rest of the pins. All right, there's our programming header. I guess let me make sure I can program it before we get too far, just in case this is got a one-off weird something or other. It glows, that's a good sign. Let us burn the bootloader. Oops, let's reset this. Let us burn the bootloader. Very good. We'll figure out what program goes on there in a second to hopefully cement our success. We will add the strangely satisfying the original hunch of a dead short is accurate. Yeah, right? Yes, but and a dead short in a weird place, right? We were dead. What were we shorting? The raw and the switch lines. So we were applying, 24 volts to this point here, which is the drain of the NDMOS switch that forms this this AL8860, which is a bad place to put 24 volts above ground, as it turns out. But not catastrophic, right? Like we didn't shut down the power supply, we didn't burn out the regulator. Yeah, fascinating. And yes, as you say, Palmer, satisfying. It was behaving like there was a short somewhere. It just wasn't between power and ground. Very cool. Oh, that's the worst. But you know what? For this Frankenboard, I think... Ooh. Oh, I gotta be really gentle with these bodge wires in the back here. You stay. Can't go whipping it around. All right, regulator. Goes in the correct orientation. Gets soldered in place in one go, because we don't care if it stands up straight. 1, 2, 3 pins. Great. Let's take our much mangled LED. We're just gonna snip that right off the board there and solder it into the new board. I can taste. Do we get to see a light ballyhoo tonight? What would we have to do? We'd have to replace the control board in one of these, which I might be a little beyond what I have the steam for this evening. I mean, I can set the other lights up, the version 9.1s to ballyhoo, but that we've already seen. Now at this point, I mean, we saw, Chris, if you scroll back in the replay, you saw those two lights ballyhooing noisily right at the beginning of the stream. So if you use your imagination, that those two lights that were ballyhooing at 7 o'clock Central were also glowing, and that's what it would look like. Yeah, but no, I know, it's not the same. Oh, this is not a good connection. Put a little of that hot juice on there. Get in there. All right, so I got my LED. I've got my regulator. I've got my Phoenix connector. I can just... This is another nice thing about the Phoenix connectors, Palmer. It's like, oh, this is a useful set of wires. I'll steal it from this board, plonk it into this board. Okay, so now, why don't we upload that same code we were just messing with? That was, you know, on for 5 seconds and then just blink our little indicator. Oops, an error occurred. Upload that. The little green indicator light on the board is also hooked up to what is the MOSI line of the Atmega, which means that it it turns on when you're programming, which is kind of a useful way to know like the programming is happening. Stand by. Now that's hydration. Okay. Code uploaded. Shall we? Let's check our voltage. Shall we give it a try? Give you a shot at the table. So again, so this should, after power on, should wait a couple seconds. Turn the light, the LED and the green light on the board on for 5 seconds. Turn off, wait 1 second, and then be blinking a green LED. Hopefully. If it doesn't work, it's possible that this bodge wire has come loose, so it might be a simple dumb thing. Or there might be something else totally wrong. I so want this to work. I have a tiny bit of beer left. That's either going to be my victory or my despair sip in a moment here. I'm just going to have that on standby there. All right. Let's hook this up, and we will turn it on. Here goes nothing. Oh. Power. Well, that's terribly anticlimactic. But, like I said, there is one obvious fix. Oh, yeah, that burns. Let's see. Oh, I may be just... Well, that's actually... I'm starting to lift the copper trace with this wire here. We did program, because it started blinking there like we thought it would. I guess the other option would be to, instead of bodge wiring to these vias, is to bodge wire to something just a little bit better. So that would be what? So I'm removing the connection between switch pin, which is pin 1 on the AL8860, and that goes to the... Oh, this would be... I can solder it to the outside edge of the inductor and pin 1 over here. Maybe that's just better. Let's just... Do we get more... Oh, sorry, was I... Yeah, my VJ for myself skills are clearly sliding downhill this evening. You know, I would like to make use of some stranded wire, just so I'm not putting as much strain on this board. I'm just gonna use this old dead DuPont wire. Cottony 280 for now that I ripped the bodge off already, Palmer. Got too much momentum. Too much hubris. All right, I think there's a good spot to bodge to in here. So rather than soldering to those vias, I'm going to solder directly to a couple of the components on the top side here. Ride the hubris. Ride the hubris really should have been the title of tonight's stream. right, that's a decent bodge. I'll take that. And then the other end of this just goes to the outside of this inductor. That's a real easy spot to solder too. So yeah, I'm just gonna solder right to this big beefy boy. This is the component, and I had a whole YouTube video about this. This is how I know, Palmer, that GLC PCB will check your part footprints for you, because I goofed this inductor the first time I laid it out, and they were like, hey, you spec this part, and here is where it goes in your circuit board, and see how those things don't line up? You sure? You sure, bud? Which is great. I mean, like, for an incredibly low-cost service, that's so much more than I would ever expect them to do. All right, that seems decent. That seems decent. Okay. Still might not mean it works, but could be progress. Plug in power supply. Turn on power supply. Oh! And off. And no flame. And no sparks. And no Bernie. No hot, no heat. Voltage regulator. Oh. There it is. We have seen the light. Oh. That's why we do this. That felt so good. Oh, yes. Stand by. It feels so good. It feels so good. Yeah, that's tremendous. Let's fade it up and down. We got the capability. We can do anything. Best in the world. Can do it all. Let's see. Where was our fading code? Here it is. Our old code, remember? Remember when we were gonna fade? Back in the midst of time when we were, you know, so confident it was a simple error. Here we go. Let's program that. Put that on the program and smoke it. Ooh, Cookie, you're not the hero I deserve, but you're the hero I need. Because even in the midst of all this chaos, you're the voice of reason. And yes, I should put a heatsink on this LED before it smokes. I'm gonna steal the one off that other LED when I can find it. Here. Just gonna rip that guy off. I've ripped the wires off this LED. I don't care. Wow, this adhesive is really good. I actually may not be able to steal this. Huh. There we go. Whew. All right. Yes. Nice big heat sink. Chunk. Let us upload some code. And we shall turn on the thing. And it fades. Ooh. Ah. That's actually not quite what we wanted it to do. We wanted it to fade up and down. Let's reset the programmer. Let's fix the code. Because it's got, if we're going to take a victory lap with some fadey fades, then it better be right. Oops. You turn off. That flickering is what happened when I had the AVR programmer plugged in and then turned off the 24-volt power, which is weird. That it was still trying to maintain some semblance of dimming. I don't know why it would do that, but don't break your anchor on the victory lap. Ah, ooh, a breathing LED. Ooh, I can warm my hands by the light of my own hubris. Ooh, here, let's turn the lights off, and we can just enjoy. We can just enjoy a nice. Well, I mean, I was gonna say a nice warm glow. It's actually fairly Halloween-esque. It's not the best, but oh yeah. How about more fire? I cannot. I mean, I. That's not a lie. I totally can. I cannot believe that we ended up in a fiery place tonight. That we actually had a thing like glow orange and smoke like that. I mean, that's just the things that happen around here, I guess. Yeah, I would love to stick the whole thing into a light and ballyhoo it for us, but like given the amount of bodging that we've seen is necessary to make this thing work, I'm just not gonna get there tonight. Might be time for a next version. Doing these on like a 2-week cycle actually seems to have been pretty great because my order time from China is just over a week. So this gives me like a couple days after the stream to make whatever adjustments I have learned, order a new set of PCBs, get them in, and, you know, hopefully get them wrung out before Sunday night, and then we can play with them on Sunday night and see whether they work or whether they don't. So, yeah, we'll be back at Demilight in a couple of weeks to play with this again, but I think I'll put a little diffuser over it. That doesn't help much, does it? So this is going to its maximum currently calibrated brightness, which is 500 milliamps, and it's still kicking bright. So I think this is going to be a great light level for us in a sustainable way. Yeah, thanks for sticking it out with me, y'all. This was a heck of a time. We went down a bunch of rabbit holes. We went down a bunch that were, I think, really valuable and turned out not to be right. We glanced by the right answer early on and came back to it later, which, you know, happens a lot. Yeah, and I'm excited to do some stuff with RDM. I think that's going to be a really useful add-on to this system, right? Is to be able to just like plug in a bunch of lights. Now that we have, again, thanks to Palmer and others who are in the connector brainstorming stream, there's the camera, like this like really easy to plug and unplug system makes such a difference for working with these things. I can't even tell you. They feel a little bit more like real fixtures, and a little less like toys, even though this one is like in full toy colors, which I love. So yeah, I'm excited. I think this is going to be a real blast. So yeah, next weekend, so as I mentioned, like we do stuff in the off weeks, which is weird to think about because it was the regular weeks for a while. Starting on Tuesday, December 1st, is the start of Advent of Code, which I plugged in last week's stream, but I should do again because I just think it's really cool. If you go to, I think it's codeadvent.com, is that true? Adventofcode.com. You get basically a daily coding challenge for every day in December, and they're non-language specific. So like if we look at the ones from 2019, it's you know, the first puzzle, and it's not super germane what exactly it is, but it's, you know, basically take a list of lines, and for each of those lines, divide by 3 and round down, and then sum up all those results. Here's your list of 100 lines, what's your results? And you put it in, and you get a point. And then it sort of expands on that problem. And you do this 25 times over the course of the month, and it's a really good way of building familiarity with whatever your language of choice is. I do mine in Python, because that's the language I know sort of best and want to learn more about the intricacies of. But it's a really fun way to, like, learn problem solving. So this all to say, next week, on the off weeks when we talk about, you know, Raspberry Pi and Python programming, I think next week is going to be an overview of solving the kinds of problems that you see in these kind of challenges, and like a look at the first 5 or 6 days. So if you are going to participate, and even if you're like, I don't know, 25 days seems like a lot to commit, I encourage you try the first 2 or 3. Because they start soft and they build up over the course of the month, so give it a try. We'll talk about the first 5 days next Sunday night at 7 p.m. here on YouTube. And I think, oh, this is kind of bold, I think we're going to try and do day 6 live together. This is another exercise in like problem solving and troubleshooting, but next week very much on the software side, where this week was the hardware side. So I think, I don't know, if you enjoyed tonight, I think you'll enjoy next week, even if programming is not your thing. If not, I'll see you in 2 weeks for Demilight version 9.0.9.4, the part that doesn't have the short circuit in it. Yeah, I think that'll be a fun time. I'm going to turn Mr. Victory Lap off because he's hurting my eyes. Thank you all so very much for hanging out with me. It's good to see you all here on the Sunday nights. If you have questions in the meantime or want to like shout out, Twitter, Jeffers Glass is the easiest place to find me. You can find information about this project, really, such as it exists, at jeff.glass/Demilight. Yeah, that's really all there is to say. Y'all are great. Thanks, nerds. It's cool to hang out on Sunday nights with a bunch of nerds and figure out some things. So, in the meantime, stay safe out there. Please treat yourselves well. Get lots of sleep. Drink lots of water. Wash your hands. Wear a mask. And I will see you all. See all you great ducks quacking our way. Maybe quacks. Maybe it's. I'll see all you great quacks. I think that was your joke, Dave. I like it a lot. Flock well. Enjoy lots of seed. Don't get stuck in any frozen lakes. And I will see you soon. Next Sunday, the Sunday after. Happy holidays, y'all.